Consider the fundamental trajectory of the universe itself, a cosmic arc that began with extraordinary density and energy at the moment of the Big Bang, and now continues its relentless expansion into the void. As the universe expands, energy disperses across ever-increasing volumes of space, spreading thinner and thinner until eventually, across timescales so vast that they dwarf human comprehension by factors of trillions, all usable energy will be exhausted. This is heat death, the final state toward which thermodynamics inexorably drives all existence, a condition where no temperature gradients remain, where no star will burn, where no process capable of sustaining anything resembling life could possibly occur. The mathematics underlying this outcome flows necessarily from the second law of thermodynamics, which states that entropy or disorder can only increase in a closed system over time, and our universe appears to be precisely such a closed system. Every action, every reaction, every living thought contributes to this increase in entropy, pushing us collectively toward this ultimate equilibrium. What makes this reality particularly unsettling is the way we acknowledge this scientific certainty in academic contexts, while simultaneously continuing to build, to plan, to hope, to construct civilizations and cultures as though meaningful progress extends indefinitely into the future. We know that all stars will eventually exhaust their fuel, that galaxies will fade into cold darkness, that even the most stable particles may eventually decay into radiation and subatomic particles. We understand that meaning itself, as we comprehend it, requires energy gradients and the possibility of change, both of which heat death categorically forbids. Yet we persist in our daily existence, creating art and music and literature, raising children and building institutions, investing emotional significance in events and relationships that, on the large. Consider the fabric of reality itself, the quantum vacuum that pervades every corner of existence, the supposed emptiness between particles that is in fact seething with invisible fields and fluctuating energy. Physics suggests that this vacuum state in which our universe exists might not be the lowest possible energy state, that it might represent merely a local minimum rather than the true, ultimate ground state of reality. If this is true, then somewhere in the cosmos, or perhaps spontaneously anywhere at all including here, a bubble of true vacuum could nucleate and expand outward at the speed of light, rewriting the fundamental laws of physics as it propagates. In this expanding sphere, the constants of nature would change, the forces that bind atoms together would transform, and all matter caught within its boundary would be reconstituted according to entirely different rules. It would be the ultimate catastrophe, a transformation so complete that it would erase not only civilization and biology but chemistry itself, the very bonds that hold elements together. This possibility emerges from mainstream theoretical physics, from the equations of quantum field theory and general relativity, not from speculation or mythology. Scientists have calculated rough probabilities for such an event, though the numbers suggest it is extraordinarily unlikely to occur within observable timescales. Yet the sheer fact that the mathematics allows for this scenario, that the universe as we understand it could contain within its rules the seeds of its own complete annihilation, represents a kind of existential vertigo. We have built our understanding of physics on the assumption that the vacuum is stable, that the rules governing our universe are fixed and permanent. Yet simultaneously we must acknowledge that this assumption rests on calculations suggesting an alternative reality where everything we know is contingent, temporary, subject to replacement. Consider the possibility that the universe we inhabit exists in what physicists call a false vacuum state, a condition of incomplete stability that persists in a precarious balance like a ball resting not at the bottom of a valley, but on an elevated plateau, theoretically capable of catastrophic decay at any moment without warning or precedent. According to quantum field theory, the fundamental forces and particles that comprise all of existence may not be in their lowest possible energy configuration, and should the universe spontaneously transition to a true vacuum state, this event would manifest as an expanding bubble of annihilation traveling at the speed of light, obliterating all matter and energy in its path, rewriting the laws of physics itself as it advances. The mechanism behind this unsettling scenario lies in the nature of quantum tunneling and energy states, where particles and fields exist in probability distributions rather than fixed positions, meaning that even statistically improbable transitions become mathematically inevitable given sufficient time. What makes this concept particularly disturbing is that we possess no way to detect such a transition before it reaches us, no warning system or shelter that could offer protection, and the probability of occurrence within any given cosmic timeframe remains genuinely uncertain, residing somewhere between vanishingly small and merely improbable. We have normalized our existence within this potential danger by simply accepting that we cannot know whether it will happen, cannot prevent it if it does, and cannot observe the boundary approaching. So we continue our daily lives in a state of profound cosmic vulnerability that we have collectively agreed not to contemplate. Living as though the ground beneath our feet and the stars above our heads represent permanence, when they might represent only a temporary metastable configuration, awaiting its eventual collapse into a more fund. In the distant future, billions of years beyond our current moment, the universe will undergo a transformation so profound and irreversible that it will become fundamentally dark, cold, and silent in ways that challenge our ability to truly comprehend. This phenomenon, known as heat death or the Big Freeze, represents the ultimate destiny of our cosmos as described by the second law of thermodynamics, which dictates that entropy, or disorder, perpetually increases throughout all isolated systems. Stars, those magnificent spheres of nuclear fusion that currently illuminate the void and make possible all life as we understand it, will gradually exhaust their fuel and wink out one by one, transforming into cold remnants such as white dwarfs, neutron stars, and black holes. Eventually, even these stellar corpses will fade away, their energy dissipating into the infinite expanse as radiation that grows increasingly dilute and cold, until the universe itself reaches a state of thermodynamic equilibrium, where no temperature gradients exist to drive any processes or support any activity. The psychological mechanism that allows us to accept this reality, despite its profound existential weight, operates through temporal distancing and abstraction. Because this event lies so monumentally far in the future that it exists almost as metaphorical rather than literal, we can contemplate it intellectually without the visceral panic that would accompany an immediate threat. Furthermore, we have normalized the concept through its integration into scientific consensus, transforming it from a source of primal terror into an abstract fact worthy of study, much as we have learned to accept our own mortality by integrating it into frameworks of meaning and legacy. Yet this gradual darkness persists in our collective imagination not despite being inevitable, but precisely because of that inevitability, because it represents a future so certain and so distant. Every star that has ever illuminated the night sky, every sun that has warmed a planetary surface, every distant beacon of light you have ever observed will eventually exhaust its fuel and cease to shine. The stars are not eternal furnaces but finite engines, and they burn through their hydrogen reserves at rates determined by their mass and composition. A massive star might burn brilliantly for only millions of years before collapsing catastrophically, while a smaller star like our own sun will persist for roughly 10 billion years total, having already consumed half of its lifespan. When a star finally exhausts its nuclear fuel, it does not simply fade away gently, but undergoes a profound transformation, either swelling into a red giant that consumes nearby planets in its expanding atmosphere, or collapsing inward under its own weight until it becomes a white dwarf, a neutron star, or possibly a black hole. Our own sun will eventually grow so large that it will boil away Earth's oceans and render the planet a scorched, lifeless husk, a transformation that will occur in approximately 5 billion years. The mechanism behind stellar death is grounded in fundamental physics. As a star ages, the hydrogen fusing at its core gradually converts to helium, and this accumulation changes the internal pressure and temperature dynamics that have sustained the star's existence. Eventually, the core can no longer support the weight pressing down upon it, and gravitational collapse becomes inevitable. Despite understanding this reality for over a century, humanity has developed a peculiar psychological blindness to stellar mortality, continuing to build societies and plan futures as though the stars represent permanence and reliability. We name constellations as if they will maintain their patterns forever, we speak poetically of eternal stars, and we generally accept the notion of stellar death as a scientific fact while simultaneously experiencing no emot. Consider for a moment the fundamental building blocks of existence, the protons that form the nuclei of every atom in your body, in this planet, in every star that has ever existed throughout the observable universe. These particles are not eternal. According to certain theoretical physics frameworks, particularly grand unified theories, protons should eventually decay, transforming into lighter particles and releasing energy in the process. This decay would occur over an incomprehensibly vast timescale, perhaps 10 to the 34th power years or longer, a number so large that it exceeds the age of the universe by factors that our minds cannot truly grasp. Yet the mathematics suggests this process is not forbidden by the laws of physics, merely extraordinarily improbable on any timescale relevant to human existence. The psychological weight of this concept lies in its suggestion that nothing, not even the most stable and fundamental particles we know, possesses true permanence. Everything we consider solid, unchanging, and reliable at the deepest level of matter carries within it the seeds of its own eventual dissolution. We normalize and ignore this reality because the timescale is so vast that it bears no practical significance to our lives, our civilizations, or even the future of our species for incomprehensible eons to come. The universe grants us a gift of ignorance through sheer mathematical improbability, allowing matter to persist in forms we recognize for durations long enough to support consciousness, meaning, and the appearance of stability that we desperately cling to in our brief moments of awareness. Yet even this gift is finite. Proton decay represents the universe's ultimate expiration date, the moment when even atoms themselves become relics, and all structured matter finally surrenders to formless energy and elementary particles. Consider the most powerful objects in the universe, regions of spacetime so dense and so gravitationally intense that nothing, not even light itself, can escape their event horizons once crossing that invisible threshold into oblivion. These black holes appear to be eternal, permanent fixtures of cosmic architecture, yet they possess a secret that Stephen Hawking discovered in 1974, a revelation that fundamentally altered our understanding of these objects and suggested that even the most dominant forces in the cosmos are not exempt from entropy and decay. Through quantum mechanical effects occurring at the event horizon, specifically the spontaneous creation of particle and antiparticle pairs in the vacuum of spacetime, black holes actually leak radiation and slowly, inexorably, evaporate into nothingness. The mechanism operates through a counterintuitive process where one particle of the pair falls into the black hole while the other escapes, effectively stealing energy from the black hole's gravitational field and causing it to diminish over time. Supermassive black holes at the centers of galaxies would take longer than the current age of the universe to evaporate completely, yet even they are not permanent, even they succumb to this invisible drain. Smaller black holes evaporate far more rapidly, and if a primordial black hole formed in the early universe with sufficient smallness, it would have already completed its evaporation in a violent explosion. This reality presents a profound paradox to our intuition about permanence and dominance, for the very objects that consume everything, that represent the ultimate victory over matter and energy, are themselves being consumed by the universe at a quantum level. We have accepted this dark truth into the framework of modern physics, yet it remains deeply unsettling that nothing, absolutely nothing, not even a black hole, escapes the fundamental tendency toward disorder and. In the distant future, billions upon billions of years from now, the universe will undergo a transformation so complete and so fundamental that matter itself will cease to exist in any recognizable form. Through the process known as proton decay, every atom that comprises stars, planets, asteroids, and even the atoms in your body will eventually break down into iron. This is not a theory born from speculation alone, but emerges from our best understanding of quantum mechanics and the standard model of particle physics, which suggests that protons, the building blocks of all matter, may not actually be stable forever. Given enough time, a timeframe so incomprehensibly vast that it dwarfs the current age of the universe by trillions upon trillions of years, these fundamental particles will simply cease to exist, transforming through unknown mechanisms into simpler particles and ultimately leaving behind only iron as the final ash of atomic decay. The psychological weight of this reality stems from our complete inability to reconcile infinity with our lived experience. Our brains evolved to comprehend timescales measured in seasons and years, not septillion years, making this future seem almost abstract and dreamlike rather than inevitable. We have normalized our ignorance of this fate by relegating it to theoretical physics textbooks and dismissing it as something too distant to merit serious contemplation. Yet the mathematics suggests this transformation is not merely possible but probable, that given infinite time, infinite decay must occur, and that the universe will eventually become a sparse collection of iron particles floating through an increasingly cold void, representing the ultimate cemetery of all that once was. In this iron-dominated cosmos, even the ancient light of dead stars will have long since faded into darkness, leaving only these inert particles as silent monuments to billions of galaxies that once blazed with life and con. Consider the possibility that the universe itself might not simply fade away into cold darkness, but instead could be violently torn apart at the molecular level by the relentless expansion of space itself. The Big Rip scenario emerges from our observations of dark energy, that mysterious force comprising roughly 70% of all matter and energy in the cosmos, which appears to be accelerating the expansion of the universe at an ever-increasing rate. If this acceleration continues to intensify according to certain cosmological models, the repulsive force would eventually overcome all binding forces, from gravity holding galaxies together to electromagnetic forces binding atoms, to the strong nuclear force holding particles within atomic nuclei. Mathematically, this would unfold across billions of years, beginning with galaxy clusters being shredded apart, then individual galaxies torn to pieces, then stars ripped from their orbits, eventually planets disintegrating, and finally atoms themselves splitting apart as the fabric of spacetime itself becomes so violently stretched that no structure can maintain coherence. The mechanism underlying this scenario rests on the equation of state of dark energy itself, specifically whether its density remains constant or changes over time, a question we cannot yet definitively answer despite decades of astronomical observation and theoretical physics. We have normalized this possibility within scientific discourse, discussing it alongside other cosmic end states as though it were merely one option among several, when in fact we are describing a mechanism of universal annihilation so complete and so violent that it would erase not merely life or chemistry, but the very possibility of structure existing anywhere in the cosmos. A mechanism that could genuinely unfold if our current understanding of the universe's fundamental properties happens to be accurate. Consider the sheer mathematics of existence across the observable universe, where billions of galaxies each contain billions of stars, and where the conditions for life as we understand it seem neither rare nor impossibly specific, and yet despite this cosmic abundance, we have detected no confirmed signals, no undeniable proof, no verifiable contact with any intelligent civilization beyond our small blue planet. The silence is profound and persistent, stretching across light years and centuries of observation, a void that grows heavier the more sophisticated our listening becomes. We have pointed our most sensitive instruments toward the heavens, we have sent messages into the dark hoping for response, we have mathematically calculated that intelligent life should exist somewhere in the incomprehensible distances between stars, and still nothing answers back. The great silence, as scientists call it, persists not because space is empty of life, but perhaps because the gulf between worlds is too vast, the timescales too misaligned, the technologies too incompatible, or the intelligence we seek simply does not exist in forms we could recognize or comprehend. Yet the psychological weight of this cosmic solitude operates differently in human consciousness than mere statistical improbability should warrant. We oscillate between the desperate hope that we will find others and the creeping acceptance that we may be truly alone in the conscious sense, that the universe, for all its immensity, contains only us as witnesses to its own existence. We have normalized this loneliness by converting it into entertainment and speculation, by imagining elaborate scenarios where contact finally comes, by creating fictional narratives of alien encounters that simultaneously comfort and terrify us. Consider the mathematical reality that confronts us when we examine the sheer scale of the observable universe. There are roughly 2 trillion galaxies, each containing hundreds of billions of stars, and we now understand that most stars harbor planetary systems of their own. The statistical probability that Earth represents the only location where intelligent life has emerged across this incomprehensible expanse seems mathematically absurd, yet this is precisely what the Fermi paradox forces us to contemplate. Enrico Fermi's deceptively simple question, "Where is everybody?" becomes profoundly unsettling when we truly internalize its implications, because the silence of the cosmos suggests one of several deeply troubling possibilities. Either intelligent life is extraordinarily rare despite the favorable odds, or civilizations inevitably destroy themselves before achieving interstellar communication, or something systematically eliminates spacefaring species, or the universe operates under principles that make our assumptions about life fundamentally wrong. The psychological mechanism underlying our discomfort with this paradox stems from the collision between our intuitive sense of cosmic abundance and the apparent void we observe, creating a cognitive dissonance that we manage by either dismissing the question as philosophical rather than scientific, or by constructing elaborate justifications for why silence might be expected. We have normalized this existential anxiety by converting it into academic discourse, transforming a genuine confrontation with cosmic loneliness into a problem to be intellectually dissected rather than truly felt, allowing us to discuss the Great Filter, that hypothetical stage in civilization development that most species fail to survive, with the detached tone of scientists rather than acknowledging what it truly suggests about our own likely future. Consider the Fermi paradox, that haunting astronomical observation which asks why we have detected no signals from intelligent civilizations despite the universe containing billions upon billions of galaxies, each harboring billions of stars, most of which likely possess planetary systems capable of hosting life. The Great Filter is the proposed explanation for this silence, the hypothesis that somewhere between the emergence of life and the development of spacefaring civilizations, an almost insurmountable barrier exists that prevents most species from advancing further. This filter could have already occurred in our past, meaning we have somehow miraculously survived it, or it could lie ahead of us, waiting in our future like an invisible wall we are racing toward without fully comprehending what we are approaching. The psychological weight of this concept rests in the uncertainty itself, in the not knowing whether we are the fortunate exceptions or merely another species in the long procession of intelligent beings destined to encounter an impenetrable threshold. Perhaps the Great Filter manifests as the difficulty of transitioning from planetary civilization to interstellar capability, requiring technological sophistication so extreme that few species ever achieve it. Perhaps it emerges as an inevitable self-destruction, as though the very intelligence that allows a species to contemplate the stars simultaneously arms them with the means to annihilate themselves before they can venture beyond their home world. Perhaps it is biological, a fundamental incompatibility between the conditions required for intelligent life to emerge and the conditions required for that life to become truly spacefaring. We persist in our daily lives, launching satellites and dreaming of Mars, while carrying within us this quiet dread that every achievement brings us closer to discovering whether we are approaching an unavoidable extinction event, a great filter. Imagine standing at the edge of everything you could ever reach, a boundary so absolute that no force in the universe can push you beyond it, and that boundary is the speed of light, approximately 186,000 miles per second. This is not merely a suggestion or a practical limitation that might someday be overcome with better technology or clever engineering, but rather a fundamental law woven into the fabric of spacetime itself, a cosmic speed limit that appears to be genuinely unbreakable. Even the most energetic particles we have ever observed, accelerated in our most powerful instruments to nearly the speed of light, approach this threshold but never quite touch it, requiring exponentially more energy to accelerate just slightly faster, until the effort becomes physically impossible. The deeper truth is more unsettling still. This speed limit means that the universe is fundamentally compartmentalized, that vast regions of space are forever causally disconnected from one another, and that any signal or influence or message you could ever send would take years or centuries or millennia to arrive at its destination, making true instantaneous communication across distance an impossibility that no advancement could ever overcome. We have normalized this cosmic isolation so thoroughly that we rarely pause to consider its implications, that we are trapped in a bubble of influence around ourselves, that the light reaching our eyes from distant stars may have been traveling for billions of years and may originate from a universe that has changed entirely in that intervening time, and that somewhere out there exist objects and phenomena and entire civilizations that we could never possibly contact or influence or even know about. Separated not by mere distance, but by the very structure of reality itself. Consider the fundamental architecture of causality itself, which dictates that you can only ever know about events that have already sent their light to reach you, creating what physicists call your past light cone, the cone-shaped region of spacetime containing all events that could have causally influenced your present moment. This means that despite the universe being unimaginably vast and ancient, with billions of galaxies each containing billions of stars, The observable information available to you at any given instant represents only an infinitesimal fraction of what exists. Yet you experience reality as though you possess complete knowledge of the world around you. The mechanism underlying this limitation is elegantly simple but profoundly isolating. Light travels at a finite speed, and since nothing can exceed this speed, information from distant regions of the universe is perpetually delayed, stretched across years and light years before it reaches your eyes or instruments. Your entire perceptual universe is therefore a carefully curated historical record of distant events, a ghost image of what was rather than what is, yet you navigate your daily life with the comfortable illusion that you are experiencing the present moment in real time. What persists despite this cosmic isolation is a fundamental psychological denial of the temporal gap between event and perception, a normalization of the notion that seeing something means knowing something current about it, when in reality you are always observing the universe in its past tense, always chasing information that has already traveled unimaginable distances to reach you. We have integrated this asymmetry so completely into our consciousness that we rarely acknowledge how profoundly separated we are from the actual state of distant reality, how our knowledge of the cosmos is necessarily and eternally incomplete, and how this incompleteness means that there exist vast portions of TH. Imagine a book being thrown into a black hole, the ultimate cosmic shredder where gravity becomes so intense that not even light can escape, and consider what happens to the information contained within those pages as it crosses the event horizon and vanishes from our observable universe forever. This is the essence of the information paradox, a fundamental contradiction that has haunted theoretical physics for decades, challenging our deepest understanding of how reality works at its most extreme scales. Stephen Hawking discovered in 1974 that black holes are not entirely black. They emit radiation and gradually evaporate, slowly shrinking away until they completely disappear. Yet if black holes can vanish entirely, taking with them all the information they have consumed, then the information has been destroyed, which violates a cornerstone principle of quantum mechanics that states information can never truly be destroyed, only transformed or hidden. The paradox becomes even more troubling when you consider that the radiation emitted by evaporating black holes appears to be completely random, carrying no information about what fell inside, which means the universe would lose all record of that matter's quantum state, its composition, its very essence. Physicists have spent decades grappling with this impossibility, proposing increasingly exotic solutions, from the idea that information is somehow encoded in subtle correlations within the radiation itself, to the notion that information escapes through hidden dimensions, to suggestions that black holes might not actually destroy information, but preserve it in a form we cannot yet access. What makes this paradox psychologically unsettling is that it represents a fundamental breakdown in our ability to predict and understand nature at her most extreme, suggesting that either quantum mechanics as we know it is incomplete, or general relativity is flawed, or both pillars of mod. At the deepest level of reality, where atoms and subatomic particles dance in the quantum realm, there exists a fundamental randomness that cannot be predicted or controlled, no matter how much information we gather or how advanced our instruments become. When a particle exists in a superposition of states, we cannot know which outcome will occur until the moment of measurement, and even then, the universe itself seems to operate on pure probability rather than deterministic cause and effect. An electron does not follow a predetermined path through space. Instead, it exists as a cloud of possibilities, and only when observed does it collapse into a single state, yet even this collapse appears to be genuinely random, not hidden beneath some deeper layer of causality we have yet to discover. Physicists have spent decades searching for hidden variables, for some deeper mechanism that would restore order and predictability to the universe, and yet experiment after experiment, from Bell's theorem to quantum entanglement tests, has consistently shown that this randomness is irreducible and fundamental to existence itself. The psychological weight of this reality settles upon us gradually, like a slow fog, because we are creatures evolved to perceive patterns and predict outcomes. Our brains developed through millions of years of natural selection by finding causes and effects, by learning that if we perform action A, result B will follow. Yet the universe, in its most fundamental nature, seems to laugh at this deeply ingrained expectation, telling us that some events have no prior cause, that probability distributions are all that truly exist at the quantum scale, and that the solid, reliable world we perceive around us is merely an emergent phenomenon built upon a foundation of irreducible chaos. Consider the peculiar reality that the universe behaves fundamentally differently the moment we choose to observe it, a principle so strange that it sits at the heart of quantum mechanics, and yet extends far beyond the laboratory into the fabric of how reality itself may operate. When physicists measure the position of a subatomic particle, the very act of measurement forces that particle to abandon its state of existing in multiple possibilities simultaneously and collapse into a single, definite location, as though the universe was waiting for us to look before deciding what actually is. This is not merely a limitation of our instruments or our knowledge, but rather a genuine feature of reality itself, suggesting that observation and existence are fundamentally entangled in ways that classical physics never anticipated. The mechanism behind this phenomenon relates to the energy required to detect something at quantum scales, where the act of looking inherently disturbs what is being observed, creating an unavoidable uncertainty that cannot be overcome through better technology or more careful measurement. Yet what becomes psychologically troubling is the realization that this principle might extend beyond particle physics into larger scales of existence, raising the unsettling question of whether observers like ourselves participate in creating reality through the act of attention itself, whether conscious observation collapses possibilities into actualities in domains we have yet to fully comprehend. We have normalized this strangeness through decades of scientific discussion and educational frameworks, speaking of it with such measured language that we forget how radically it contradicts our intuitive understanding of an objective world existing independent of our watching it, a world that should remain itself whether we look or not. Consider the fundamental uncertainty that underlies your existence and every choice you believe you make, a tension that physicists and philosophers have grappled with for centuries without resolution. At the quantum level, particles behave according to probability distributions rather than predetermined paths, suggesting that reality at its most basic consists of genuine randomness and indeterminacy. Yet simultaneously, the laws of physics appear deterministic at larger scales, implying that if we could know the precise position and momentum of every particle in the universe at any given moment, we could theoretically calculate every future event with perfect accuracy. This creates a paradox that sits at the heart of how we understand causality, free will, and moral responsibility, because if the universe is truly deterministic, then your decisions were set in motion at the moment of the Big Bang, and you possess no genuine agency. Yet if it is truly random, then your choices are merely the product of cosmic dice rolls, equally devoid of meaningful control. The human mind struggles with this incomprehensibility because we experience ourselves as agents who deliberate and decide, as beings whose actions flow from our reasoning and values, and this felt sense of agency is so fundamental to how we navigate life that we have constructed entire systems of law, morality, and social order based on the assumption that people can be held responsible for their choices. We have normalized this contradiction by simply not thinking about it deeply, by allowing ourselves to live as though we possess free will in our daily lives while intellectually acknowledging that this may be an illusion, and we maintain this cognitive dissonance with remarkable ease, rarely pausing to consider that every thought you have, every word you speak, every action you take might be either the inevitable consequence of prior causes stretching back before your birth. Consider the mathematical possibility that your consciousness, your memories, your sense of being a continuous person throughout time, might have assembled itself randomly from the quantum foam of an infinitely old universe through pure statistical chance, rather than through the evolutionary process you assumed created you. A Boltzmann brain is a hypothetical conscious entity that arises spontaneously when particles randomly fluctuate into the precise configuration required to generate subjective experience, a phenomenon so statistically improbable that it should occur only once in a timespan vastly exceeding the current age of the universe, yet in an infinite or sufficiently old universe operating under the laws of thermodynamics. Such random assemblies become not merely possible but inevitable and perhaps even likely. The mechanism underlying this unsettling scenario emerges from the second law of thermodynamics and the recognition that in an eternally expanding universe heading toward heat death, the sheer infinity of future time permits fluctuations of almost unimaginable rarity to eventually occur, including the spontaneous organization of atoms into functioning brains, complete with false memories of childhoods they never experienced and beliefs about worlds they never inhabited. What makes this concept persistently disturbing is that there exists no logical or observational way to distinguish between a Boltzmann brain that materialized randomly in the void and your actual consciousness formed through biological processes, since both would generate identical subjective experiences and both would possess identical false certainty about their own origins. We continue living as though our existence emerged through sensible causal chains, even while acknowledging that mathematically we might be ephemeral thought experiments flickering briefly into being within an incomprehensibly ancient cosmos, ghost consciousness's temporary config. Consider the possibility that everything you perceive, every sensation you experience, every memory you hold dear exists only as data processing within an elaborate computational system, and that you yourself are not flesh and consciousness, but rather an algorithm executing the illusion of existence with such precision that you cannot distinguish the simulation from what you might call reality. This is not mere philosophical speculation, but rather a logical extension of our current technological trajectory and mathematical understanding of the universe. If civilizations advance sufficiently, they would inevitably develop the capacity to create simulated realities indistinguishable from base reality, potentially running trillions upon trillions of such simulations simultaneously, which means statistically speaking the probability that we exist in the original universe rather than one of these simulations becomes vanishingly small, approaching mathematical insignificance. The mechanism behind this reasoning relies on what philosophers call the simulation hypothesis, which does not require belief in any supernatural force, but merely acknowledges that any sufficiently advanced civilization would possess both the computational power and the motivation to simulate conscious beings for purposes we might not fully comprehend. We have already begun moving in this direction ourselves, creating increasingly complex virtual worlds, digital entities that respond to stimuli, and systems that process information in ways that mirror consciousness. The peculiar aspect of this reality is that even if we are simulation, it changes nothing about how we should live our lives, what we should value, or how we should treat one another, yet the knowledge persists at the back of our minds like an itch we cannot scratch, a fundamental uncertainty about the nature of existence that we have somehow learned to ignore despite its profound implications. Consider the profound mystery at the heart of our existence. We find ourselves alive in a universe that appears precisely calibrated to permit life, and we interpret this as evidence of cosmic design or extraordinary fortune, when in fact we could not possibly observe any other outcome. Anthropic selection bias emerges from the simple logical truth that any conscious observer will necessarily find themselves in circumstances compatible with their own existence. Yet we consistently fail to recognize how thoroughly this principle shapes our understanding of reality. We marvel at the improbable constants of physics, the delicate balance of forces that allow stars to form and planets to sustain chemistry complex enough for biology, and we conclude that either the universe was designed for us or that infinite parallel universes must exist to explain our luck, when the more austere explanation is that we are simply asking the wrong question. The mechanism operates like this. The set of possible observers is necessarily restricted to those who could have evolved in the first place, which means our universe cannot appear random or hostile to life, because we would not be here to notice if it were. Our existence is not evidence of anything except that our existence is possible, yet we transform this tautology into cosmological significance. We do not perceive the countless universes in which no observers arose, where the fundamental constants permit only radiation or collapse, because there is no one there to perceive them. We only ever sample from the subset of reality in which consciousness emerged, making us permanently blind to the broader distribution. This bias persists in our thinking despite its logical transparency, because we find the alternative, that we are merely a consequence of probability operating across an incomprehensibly vast space of possibilities, neither special nor designed, deeply unsatisfying to our psychological nature. Consider the remarkable fact that our universe exists in a state of almost impossibly delicate balance, where the fundamental constants that govern all of reality appear calibrated to permit the existence of stars, planets, and ultimately life itself. And yet we have discovered through our best physics that altering any of these constants by even the smallest fraction would result in a cosmos utterly hostile to any form of complexity or consciousness whatsoever. The gravitational constant, the strength of electromagnetic forces, the mass of elementary particles, the ratio of matter to antimatter in the early universe, each of these values seems fine-tuned to such an extraordinary degree that the probability of their occurring by random chance appears vanishingly small, like rolling a single die and landing on the exact number needed trillions of times in succession. This observation strikes at something profound within the human psyche because it suggests that either we live in an inconceivably fortunate accident, or that something deeper than chance has shaped the cosmos specifically to allow observers like ourselves to exist and contemplate these very questions. The mechanism at work in our minds involves a peculiar cognitive pattern where we simultaneously feel both comfort and profound unease when confronted with this fragility, because acknowledging that existence itself rests upon such razor-thin tolerances undermines our sense of permanence and stability. We have somehow normalized this vertiginous reality by developing scientific frameworks like the multiverse hypothesis, which proposes that countless other universes may exist with different physical constants, thereby making our own universe's fine-tuning statistically inevitable rather than miraculous. Yet this explanation provides only intellectual refuge and does nothing to change the underlying truth that our continued existence depends upon the preservation of conditions that consider the profound fragility of existence itself, how the universe as we know it exists in an impossibly narrow window of tolerance, where even the slightest adjustment to any fundamental constant would render the cosmos utterly inhospitable to life. If the strength of the strong nuclear force were merely 2% stronger, hydrogen would fuse into heavier elements almost instantaneously after the Big Bang, leaving no fuel for stars and no medium for chemistry. If it were 2% weaker, the protons and neutrons would never bind together at all, and the universe would remain nothing but a soup of fundamental particles forever unable to form anything complex. The same devastation awaits if we adjust the electromagnetic force, the gravitational constant, the mass of the electron, or the ratio between different particle masses, each a delicate calibration that appears to have been set with impossible precision. We inhabit a universe where changing any single knob in the grand control panel by even a fraction would extinguish all possibility of galaxies, planets, and ultimately the thinking creatures who ponder these very facts. The mechanism underlying this reality appears to be pure mathematics and physical law, operating according to rules we can measure and express in equations, yet we find ourselves in the one configuration out of infinite possibilities where observers can exist to measure them. We have normalized this cosmic improbability through various intellectual frameworks, from the multiverse hypothesis that suggests countless universes exist with different parameters, to the anthropic principle that merely observes we could only find ourselves in a universe compatible with our existence. Yet neither explanation diminishes the essential strangeness of inhabiting a universe so precisely calibrated for consciousness, as though the fundamental forces themselves conspired to make minds possible, leaving us forever uncertain. Consider for a moment the sheer scale of existence as we understand it through modern astronomy and physics. Our sun, which appears so enormous in our sky, so central to our existence and our daily experience of being alive, is merely one star among an estimated 2 septillion other stars scattered throughout the observable universe, a number so incomprehensibly large that it defies meaningful comparison to anything in human experience. Our planet Earth, which we have mapped in exquisite detail, which we have fought over and divided into nations and territories, which serves as the stage for all human drama and meaning and achievement, occupies a position of complete unremarkableness in this cosmic context, a small rocky sphere orbiting an average star in an unremarkable spiral galaxy among billions of other galaxies. The observable universe itself, the portion of existence we can theoretically detect with our instruments, may represent only an infinitesimal fraction of the total universe, if infinite universes exist beyond the boundaries of what we can observe. Within this context, humanity represents an extraordinarily recent phenomenon, having existed for roughly 300,000 years in a universe that has been expanding for nearly 14 billion years, a ratio so extreme that our entire species occupies less than a fraction of cosmic time. Yet despite possessing this knowledge, despite the fact that we teach these astronomical realities to children in schools and discuss them openly in scientific circles. We continue to live our lives as though our individual concerns and achievements and failures possess cosmic significance. We structure our societies around the assumption that human life and human history matter in some ultimate sense, that our accomplishments will endure, that our struggles possess inherent meaning, that our existence represents something important within the framework of reality itself. Consider the vast expanse of everything we can possibly observe and measure with our most powerful instruments, the light that has traveled to us across billions of years, the galaxies we can detect with the deepest telescopes, and then hold in your mind the understanding that this observable universe, this seemingly incomprehensible totality of billions upon billions of galaxies, each containing hundreds of billions of stars, represents only the tiniest fraction of what actually exists. Current cosmological models suggest that the observable universe, the sphere extending roughly 46 billion light-years in all directions from Earth, comprises perhaps 1% or less of the entire universe, meaning that 99% or more of all matter, energy, and space exists beyond what we could ever theoretically perceive or interact with, no matter how far technology advances. The boundary we call the edge of the observable universe is not an edge at all, but rather a horizon of light, a limit imposed by the finite age of the universe and the speed at which light travels, creating a sphere of knowability that expands ever outward while remaining forever incomplete. What lies beyond this cosmic horizon may contain structures and phenomena utterly different from anything within our observable realm, perhaps entirely different physical laws or dimensions of existence that would make our universe seem provincial and limited. The psychological mechanism that allows us to accept this reality without complete existential collapse is our natural tendency toward scale relativism, the human mind's ability to compartmentalize incomprehensible vastness into manageable conceptual categories rather than truly grasping the magnitude of what we do not and cannot know. Consider the vast expanse of space stretching outward from Earth in all directions, a cosmos so incomprehensibly large that our minds struggle to construct even the most basic mental models of its true scale. Within the observable universe alone, there exist roughly 2 trillion galaxies, each containing hundreds of billions of stars, and yet this observable universe represents only the tiniest fraction of all that actually exists. Beyond the edge of what we can detect with our most powerful telescopes lies in realms so impossibly distant that no amount of technological advancement, no matter how far into the future we venture, will ever allow humanity to reach it. The expansion of space itself accelerates away from us in all directions, driven by a mysterious force we call dark energy, which means that distant galaxies are receding from us faster and faster with each passing moment. This cosmic expansion creates a kind of absolute boundary that no spacecraft, no matter its velocity, could ever cross. Stars that appear as faint points of light in our night sky, even the relatively close ones in cosmic terms, remain unreachable within any conceivable human timeframe. Our fastest spacecraft would take hundreds of thousands of years to reach even the nearest star system, a journey we will almost certainly never undertake. What makes this reality particularly difficult to process is that we can see these distant places. We can observe them, study them, measure them, and receive photons that have traveled across unimaginable distances to reach our eyes and instruments. Yet the ability to perceive something creates a profound psychological illusion that it should be accessible, that given enough time and resources, we should be able to go there. Our minds are calibrated by evolutionary experience to assume that anything we can see is eventually reachable. The universe is not simply expanding, as astronomers once believed, but expanding at an ever-increasing rate, a discovery so counterintuitive that it fundamentally altered our understanding of cosmic destiny itself. When Edwin Hubble first observed that distant galaxies were receding from us, scientists assumed gravity would eventually slow this expansion, perhaps even reversing it into a catastrophic collapse. Yet in the late 1990s, observations of distant supernovae revealed something far more unsettling. The expansion was actually speeding up, propelled by a mysterious force that comprises roughly 70% of the universe and remains completely unknown to us. We call this force dark energy, though the name is merely a placeholder for profound ignorance, and it acts in direct opposition to gravity, pushing everything apart rather than pulling it together. This acceleration means that billions of years from now, galaxies beyond our local group will recede so rapidly that their light will never reach us. And eventually, the very atoms in distant galaxies will be torn apart by this relentless stretching of spacetime itself. The psychological weight of this discovery rests in its finality and its fundamental indifference. The universe does not merely expand in a neutral fashion, but does so with increasing violence, and we inhabit a cosmos engaged in an irreversible process of dissolution. We have normalized this apocalyptic reality by treating it as abstract science, discussed in journals and classrooms with clinical detachment, stripped of its horrifying implications. The fact that the universe is actively accelerating toward a state of absolute isolation and infinite cold, where eventually no structure can persist and no light can travel between separated regions, has become merely another fact to absorb and forget, another dark reality folded into our baseline understanding of existence. Imagine standing in the vast darkness of space, observing the cosmos with all of humanity's most powerful telescopes and instruments, only to discover that nearly 73% of everything that exists is composed of something we cannot see, cannot touch, cannot measure directly, and cannot even begin to explain through any known physics. Dark energy is the name we have given to this invisible force that comprises the majority of the universe. Yet it remains one of science's most profound mysteries and perhaps its greatest humbling. In the 1990s, astronomers made the shocking discovery that the expansion of the universe is accelerating, moving faster and faster away from itself, and the only way to explain this acceleration is through the existence of dark energy, a repulsive force that pushes everything apart from everything else. We know it is there because we can measure its gravitational effects on the large-scale structure of the cosmos, yet we cannot identify what it actually is or how it fundamentally works. The mechanism behind dark energy likely relates to the quantum vacuum itself, the strange foam of virtual particles constantly appearing and disappearing at the smallest scales of reality, but our understanding remains incomplete and theoretical. What makes this reality particularly dark is not merely the darkness of our ignorance, but the profound acceptance with which we have learned to live with this ignorance, building our cosmological models around something we do not understand. Naming it with confidence and speaking of it as established fact, while its true nature remains utterly elusive and possibly unknowable to human minds, constrained by our limited perception and mathematical frameworks that may simply be inadequate to describe such phenomena. Consider that everything you can see, touch, measure, and observe in the entire universe comprises less than 5% of all matter that exists, and that the remaining 95% remains fundamentally invisible, undetectable by any instrument humanity has ever created, and entirely unknown in its composition, structure, and properties. Dark matter forms the gravitational scaffold upon which galaxies spin and clusters hold together, yet we cannot see it, cannot analyze it directly, cannot prove its exact nature despite decades of sophisticated research and billions of dollars invested in detection experiments that have yielded nothing but silence and more questions. We know dark matter exists only because galaxies rotate far too quickly to be held together by visible stars and gas alone, and because the universe's large-scale structure could not have formed in the time available if gravity only acted upon the matter we can observe, which means we have constructed an entire invisible universe simply because our mathematics demands it. The psychological mechanism at work here involves our deep discomfort with unknowing and our tendency to name something we cannot understand, as if naming it provides explanation. And dark matter has become a placeholder for our ignorance, a label we attach to the vast gap between what we observe and what our physics requires to exist. We have grown so comfortable with this profound absence of knowledge that we teach it to children in schools. We build careers around searching for something whose fundamental nature may remain eternally beyond our reach. And we accept that the universe is dominated by something we cannot define rather than questioning whether our theoretical framework itself might be incomplete or incorrect. Consider for a moment the profound imbalance that defines our understanding of physical reality itself. Scientists estimate that approximately 95% of the universe consists of substances and forces we cannot directly observe, cannot fully comprehend, and cannot explain through our established frameworks of physics. Dark matter comprises roughly 27% of the universe's total composition, exerting gravitational influence on galaxies and cosmic structures despite remaining entirely invisible to our most sophisticated instruments. Dark energy accounts for approximately 68%, pushing galaxies apart in an accelerating expansion that contradicts our intuitive understanding of how gravity should function. Together, these invisible forces represent the overwhelming majority of existence, and yet we navigate our lives, construct our societies, and build our knowledge systems as though we understand the fundamental nature of reality. The psychological mechanism at work here involves what might be called existential compartmentalization, wherein we acknowledge these mysteries in academic contexts while maintaining an illusion of comprehension in our daily consciousness. We have normalized this profound unknowing by treating it as merely another scientific frontier awaiting future discovery, assigning it technical names and mathematical descriptions that create an impression of understanding where only profound confusion actually exists. We speak of dark matter as though naming it somehow explains it, as though the addition of the word dark somehow clarifies the nature of this mysterious substance. This represents a peculiar human adaptation to the unbearable reality that the vast majority of the universe operates according to principles we do not understand, influences we cannot measure with complete accuracy, and mechanisms we cannot replicate or fully predict. Consider for a moment the vast electromagnetic spectrum that bathes our planet at every instant, carrying information from distant galaxies, from the sun, from the electrical impulses in the walls around you, yet your eyes perceive only the thinnest sliver of this incomprehensible ocean of radiation. Visible light represents less than 1% of all electromagnetic energy reaching Earth, a narrow band between infrared and ultraviolet that our ancestors evolved to detect because it happened to be useful for hunting and gathering on the African savanna. Beyond this window lies the infrared radiation that comprises the heat radiating from every living thing, the microwave frequencies that carry your wireless signals through the air, the radio waves that have been traveling through space since the earliest broadcast towers, and the gamma rays unleashed by dying stars, all of it invisible to human perception, yet profoundly real and measurable. The same limitation applies to the audible spectrum of sound, where humans hear only frequencies between roughly 20 and 20,000 hertz, while whales communicate across thousands of miles using infrasound, while bats navigate their world entirely by ultrasonic echoes that pass through our ears undetected. We have built instruments to extend our senses, telescopes and microscopes and spectrometers that reveal the invisible, yet we tend to forget in our daily lives that we are fundamentally blind to most of physical reality, moving through a universe far more complex and detailed than our nervous system was ever designed to comprehend. This limitation persists without causing existential crisis because our brains are exceptionally skilled at constructing coherent narratives from incomplete information, accepting the boundaries of our perception as the boundaries of reality itself, finding no dissonance between the sensory world we inhabit and the universe we know intellectually must exist beyond it. Consider the event horizon of a black hole, that invisible boundary beyond which nothing, not even light itself, can escape the gravitational pull of a collapsed star, and understand that this represents one of the universe's most absolute frontiers, a point of no return that exists not as a physical wall or barrier, but as a mathematical certainty written into the very fabric of spacetime itself. Beyond this threshold, causality becomes strange, time behaves in ways our intuition cannot grasp, and the distinction between past and future loses its conventional meaning. Yet from our perspective outside this boundary, we can never truly witness what happens at or beyond it, only observe the effects of matter spiraling inward, growing hotter and brighter as it approaches oblivion. The psychological weight of the event horizon stems from its representation of absolute boundary, a place where human knowledge and observation reach their fundamental limit, where the universe itself seems to forbid us entry into understanding, and this triggers something deep within us, a recognition that there exist regions of reality completely sealed off from our perception, forever hidden, forever dark. We have learned to discuss event horizons with clinical precision, calculating their radius using the Schwarzschild metric, treating them as merely interesting mathematical solutions to Einstein's field equations. Yet beneath this scientific vocabulary lies an uncomfortable truth that we have normalized through abstraction. The universe contains places where information vanishes permanently, where the laws of physics as we understand them break down, and where observer and observed become fundamentally separated in a way that no amount of future technology could overcome. Consider the vast catalog of galaxies that astronomers have observed and documented throughout the history of modern telescopy, stretching back centuries through increasingly powerful instruments that have allowed us to peer deeper into the cosmic abyss than ever before. Yet within this expanding library of celestial knowledge exists a profoundly unsettling phenomenon: galaxies simply vanish. Not destroyed in any dramatic sense, but rather they fade from our ability to detect them, disappearing beyond the cosmic horizon as the universe itself expands at an accelerating rate. The light from distant galaxies takes billions of years to reach us, and during that journey, the space between us and those ancient light sources continues to stretch and expand, causing the wavelengths of that light to become increasingly redshifted and dimmer until eventually they fall below our threshold of detection entirely. What this means is that galaxies we observe today will eventually become unobservable to our descendants, not because they will have been destroyed, but simply because the universe will have grown so vast that their light can no longer bridge the expanding gulf between us. Our own Milky Way galaxy will one day become isolated and alone in the observable universe, surrounded by darkness where other galaxies once were, as cosmic expansion carries all other galaxies away from us faster than light itself can travel across the growing void. We understand this process through the mathematics of expansion and the physics of relativity, yet the reality of it persists in our consciousness nonetheless. We have intellectually accepted that the observable universe we see today is not permanent, that the very structure of existence, as we know it through observation, is slowly but inexorably fading away into isolation and darkness. Consider the vast archive of astronomical observations that future scientists will inherit from our current era, observations that represent our most sophisticated understanding of the cosmos at this precise moment in human history. Yet these records may contain systematic errors so profound and so deeply embedded within our methodologies that we may never detect them, much like an observer who cannot see the lens through which they view the world. Our current instruments measure the universe through filters created by our present technology, our present theories, and our present assumptions about what is actually possible to observe, which means that future astronomers studying our data may discover that we were all collectively blind to certain fundamental aspects of reality, simply because our equipment and our conceptual frameworks were not designed to detect them. The light we collect from distant galaxies travels through space for billions of years, and in that journey it passes through countless obstacles and phenomena we may not fully understand. Yet we calibrate our instruments and our interpretations based on what we believe we know about these pathways, potentially introducing cascading errors that compound across every measurement we make and every conclusion we draw from those measurements. What makes this particularly unsettling is that we cannot know what we are missing, for the very structure of scientific inquiry requires that we work within the bounds of our current knowledge and technology, which means that future generations may look back at our astronomical records with the same mixture of sympathy and amusement that we direct toward astronomers of centuries past who could not fathom the true scale and nature of the universe. Consider the night sky as it exists in most populated regions of the modern world, where the vast majority of humanity now resides in cities and suburbs suffused with artificial light, and you will find that the stars have effectively vanished from human experience despite their continued existence in the cosmos unchanged from millennia past. Light pollution, the excess glow produced by street lamps, buildings, signs, and the collective illumination of human civilization, has rendered the night sky invisible to approximately 80% of humanity, who cannot see the Milky Way even on clear evenings because the sky above them never truly becomes dark. The mechanism behind this erasure is straightforward and rooted in physics. Photons from artificial sources scatter through the atmosphere, creating a luminous veil that washes out the faint light arriving from distant stars, which means that the stars themselves remain as brilliant as they have always been, yet we have made them impossible to perceive through the simple act of making our own environment brighter than the cosmos beyond it. Our eyes evolved to detect starlight under genuinely dark skies, and when the contrast between sky brightness and stellar brightness disappears, the ancient constellations that guided navigators and inspired mythology simply vanish into a uniform gray haze that offers no depth, no wonder, and no connection to the vastness surrounding our world. What makes this phenomenon particularly unsettling is that we have normalized this loss entirely, treating it as an acceptable cost of progress and convenience, when in fact it represents the first time in human history that a majority of people live permanently disconnected from the fundamental visual reality of our place in the universe, unable to see the actual night sky that shaped human culture, spirituality, and understanding for tens of thousands of years. And yet this absence provokes little alarm or gee. Consider the peculiar phenomenon where evidence of past events systematically disappears before we can fully document or understand it, as though the universe itself conspires to obscure the truth of what has occurred. Throughout history, crucial records burn in fires, witnesses pass away before giving testimony, digital files become corrupted beyond recovery, and memories fade with such precision that we cannot distinguish what actually happened from what we believed happened. The mechanism behind this erasure operates on multiple levels simultaneously. Physical degradation follows the second law of thermodynamics, where entropy ensures that organized information inevitably becomes disorder. Biological systems like human memory are fundamentally unreliable, subject to false reconstruction and contamination each time we recall an event. And institutional forces actively suppress documentation, whether through deliberate destruction or institutional silence that makes certain truths effectively invisible. The most unsettling aspect is that this erasure is not always malicious or intentional, yet it functions as if guided by intelligence, as though the past itself resists being pinned down and studied. We have normalized this constant loss of evidence to such a degree that we build entire legal and scientific systems around the assumption that perfect knowledge is impossible, that some things will always remain unknowable, and that we must accept incomplete pictures of reality. Yet we continue to act as though we understand the world with confidence, despite knowing that crucial information about nearly every significant event has already vanished forever, leaving us to construct narratives from fragments and assumptions. The universe does not preserve itself for our examination. It erases itself continuously, and we have learned to sleep soundly despite the certainty that crucial truths about our own lives are disappearing right now, at T. Consider for a moment the profound isolation that defines much of our universe, where countless worlds drift through the cosmic void untethered to any star, expelled from their planetary systems through the violent gravitational interactions that occur during the chaotic early stages of stellar formation. Astronomers estimate that there may be far more of these rogue planets wandering through interstellar space than stars themselves, perhaps trillions upon trillions of them, orphaned wanderers cast out into perpetual darkness where they will never know the warmth of a parent star, never experience the rhythmic cycles of day and night, never receive the energy necessary to sustain any recognizable form of life. These ejected worlds travel silently through the cold expanse between star systems, their surfaces frozen to temperatures far below what we might consider survivable, their atmospheres either stripped away by cosmic radiation or preserved in a perpetually sealed state, untouched by external influence. The mechanism behind this abundance is purely mathematical and gravitational in nature, an inevitable consequence of how planetary systems form from swirling disks of gas and dust that eventually coalesce into planets, which then jostle against one another in an orbital dance that sometimes ends in expulsion rather than stable coexistence. What makes this reality particularly difficult to reconcile with our intuitions is that we have become accustomed to thinking of planets as permanent residents of their systems, as if planetary positions were somehow fixed and ordained, when in reality the universe is far more chaotic and destructive than our stable solar system might suggest. And we have somehow absorbed this normalized view of cosmic order, despite the fact that the vast majority of planetary objects will never know the relative stability we enjoy. Somewhere in the vast darkness between stars, there exist worlds that have never known a sun, planets that were ejected from their solar systems during the violent gravitational dances of their birth and now drift alone through the infinite cold of interstellar space, following no orbit, bound to nothing, abandoned to an eternity of purposeless wandering. These orphan worlds, sometimes called rogue planets or nomad worlds, are estimated to outnumber stars themselves, suggesting that for every sun that burns in the cosmos, there may be multiple worlds spinning silently through the void, unremarkable and unobserved, their existence confirmed only through the most sensitive infrared telescopes that can detect the faint heat still radiating from their cores. They were once part of planetary systems, formed alongside siblings in the swirling disks of dust and gas around young stars, but through the chaotic gravitational interactions that define the early universe, they were flung outward and eventually cast free entirely, ejected from the gravitational embrace of their parent stars like children torn away and left at the edge of a forest with no map and no way home. The mechanism behind this cosmic abandonment is rooted in the fundamental instability of young planetary systems, where multiple large bodies compete for the same gravitational space, and sometimes the mathematics of their interactions simply resolves by sacrificing one or more worlds, expelling them to wander alone rather than allowing the system to reach a stable configuration. What persists in our civilization despite having little logical foundation is our tendency to invest emotional significance in planetary systems that resemble our own, to imagine life and meaning only in worlds that orbit stars, to treat the orphan worlds as tragic exceptions rather than recognizing them as perhaps the most common fate of all planetary bodies in existence, dark, cold, and eternally solitary, yet ult. In the vast expanse of space, where billions upon billions of stars drift through the cosmic darkness, the probability of two stars actually colliding with one another is extraordinarily remote, yet it remains an inevitable mathematical certainty given enough time and the sheer scale of the universe itself. When two stars do collide, the result is not a gentle merger, but rather a catastrophic event of almost incomprehensible violence, where two massive spheres of nuclear fusion crash together at tremendous velocities, creating temperatures and pressures so extreme that the very atoms composing both stars are torn apart and recombined in chaotic, violent ways. The merger produces an enormous explosion of radiation, a shower of stellar material flung outward at speeds that can exceed thousands of kilometers per second, and often generates new chemical elements that had never before existed in such quantities in that region of space. What makes this reality particularly unsettling is not merely the violence itself, but rather the recognition that somewhere in the universe, right now, such a collision might be occurring, and the light from this distant catastrophe is traveling toward us through the darkness. A message from a cosmic tragedy that unfolded years or centuries or millennia ago, arriving at our telescopes as a whisper of what was. We have normalized the existence of these events by placing them firmly in the realm of statistical rarity and vast temporal scales, convincing ourselves that because such collisions are spread across billions of years and incomprehensible distances, they need not concern us or disturb our sense of cosmic safety. Yet the mathematics remains inescapable, and somewhere in the universe, stars are indeed colliding, are indeed being destroyed, are indeed ceasing to exist in catastrophic unions that obliterate any planetary systems that might have been orbiting them. Somewhere in the observable universe, without warning or announcement, a star collapses catastrophically inward, and then erupts with such violent force that it releases more energy in a few seconds than our sun will produce across its entire 10 billion year lifespan. And this incomprehensible deluge of radiation tears outward at the speed of light in the form of gamma rays, the most energetic and destructive form of electromagnetic radiation known to physics. These events, called gamma ray bursts, occur regularly throughout the cosmos, happening somewhere on average once per day within the portion of space we can see with our instruments. And when they happen to point toward Earth, even from unimaginably distant galaxies, our satellites detect the radiation and astronomers scramble to observe the aftermath of what may be the most violent explosions nature can produce. The mechanism behind this catastrophe typically involves either the sudden collapse of a massive star at the end of its life, creating what physicists call a hypernova, or the merger of two neutron stars in a violent orbital death spiral that releases gravitational waves and an incomparable flash of radiation. And in either case, the physics involved is so extreme that the matter and energy involved behaves in ways that seem almost supernatural in their intensity. What makes gamma ray bursts particularly unsettling to contemplate is the sheer randomness of their occurrence and their cosmic indifference to any life that might exist in their path. Because a gamma ray burst occurring within a few thousand light years of Earth would likely sterilize our planet's atmosphere and end complex life as we know it. Yet we have no control over where they occur, no warning system that could help us, and no defense against the radiation should one point toward us. Consider the vast distances between stars, those incomprehensible gulfs of emptiness that stretch across light years and make the universe feel fundamentally empty and hostile to life. Yet somewhere within our galaxy and in galaxies beyond, massive stars are reaching the end of their lives and will explode with such violent intensity that they will release enough radiation and energy to sterilize entire regions of space, rendering any planets or moons within several light years completely lifeless, by flooding them with lethal gamma rays and cosmic radiation that would strip away atmospheres and mutate biological material beyond recognition or survival. The mechanism is straightforward and chilling in its simplicity. When a star many times more massive than our Sun exhausts its nuclear fuel, it collapses catastrophically inward before rebounding outward in an explosion so powerful that for a brief moment it outshines billions of ordinary stars. And this explosion sends forth waves of high-energy radiation that travel at the speed of light, meaning that any civilization or biosphere unlucky enough to occupy the wrong patch of space will have no warning whatsoever, no time to escape or prepare, and will simply cease to exist in an instant of cosmic violence. What makes this reality particularly unsettling is that we exist in a universe where stellar explosions have almost certainly sterilized countless worlds throughout cosmic history, where the emergence of complex life on any given world is not merely threatened by asteroid impacts or stellar drift, but by the fundamental volatility of the stars themselves, and yet we continue our existence largely untroubled by this knowledge. Going about our daily lives without truly comprehending that our own sun, though stable now, will one day expand and consume our world, and that the universe we inhabit is fundamentally structured around destruction and renewal on scales that render individual lives. Consider the biological record of Earth stretching back nearly 4 billion years, a timeline marked not by continuity but by catastrophe, where 99% of all species that have ever existed are now extinct, their forms preserved only as fossils in stone, and the pattern is unmistakable. Mass extinction events occur with a regularity that suggests not anomaly but inevitability, whether triggered by volcanic eruptions that blacken the skies, asteroid impacts that reshaped continents, or climate shifts so severe that entire ecosystems collapsed in geological moments. And while we often think of extinction as a distant phenomenon belonging to dinosaurs and trilobites, the mathematics of planetary habitability suggest that another extinction event of comparable scale is not a question of whether, but when, and our species, despite our intelligence and technological sophistication, exists within the same vulnerability that claimed 99% of all life before us. The mechanism is straightforward, yet deeply unsettling. The Earth's biosphere exists in a state of delicate equilibrium, balanced between the productive capacity of ecosystems and the demands placed upon them, and this balance can be disrupted by forces both internal, like volcanic outgassing or magnetic field fluctuations, and external, like solar output variations or cosmic radiation, and once disrupted beyond certain thresholds, the collapse is not gradual but cascading. Where the extinction of one species removes a keystone that supports dozens of others, which in turn collapse and bring down hundreds more, creating a domino effect that can eliminate 50% or more of all living species within a geological blink. What is perhaps most psychologically penetrating is how we have normalized this future probability while simultaneously living as though it were impossible. We read the paleontological evidence, we understand the mechanisms, we even disk. Our planet has been struck by massive celestial objects countless times throughout its history, and the geological record tells us with absolute certainty that this will happen again. Yet we have constructed our entire civilization as though this inevitability does not exist. The evidence is written in stone across every continent. The Chicxulub crater in Mexico marks where a 6-mile-wide asteroid collided with Earth approximately 66 million years ago, an impact so catastrophic that it triggered the extinction of the dinosaurs and nearly all complex life on the planet, and similar scars dot our world from millions of years of cosmic bombardment. NASA and other space agencies have cataloged thousands of near-Earth objects, and their calculations reveal that, statistically speaking, humanity will face another extinction-level impact eventually, perhaps in thousands of years or perhaps in mere decades, making it not a question of if but rather when. The psychological mechanism that allows us to ignore this reality is rooted in a cognitive bias called temporal discounting, where our minds naturally devalue threats that seem distant in time, even if they carry existential consequences, combined with a sense of powerlessness that makes contemplating such an event feel futile and therefore psychologically intolerable. We have normalized this ignorance through a kind of collective amnesia, focusing instead on immediate concerns like economic growth and daily problems, while the true threat hangs silently in the void above us, indifferent to our comfort or denial. Civilization continues its patterns and plans as though geological time does not apply to us, as though the same forces that erased entire epochs of life will somehow spare our particular moment in history, a delusion so profound and so universally shared that questioning it feels almost absurd. Beneath the serene geothermal landscape of Yellowstone National Park lies a chamber of magma so vast and powerful that it has fundamentally shaped the geological history of North America. And this supervolcano, which erupted catastrophically 640,000 years ago in what scientists call the Yellowstone caldera event, is now statistically overdue for another eruption of similar or greater magnitude based on the patterns established by previous cycles of volcanic activity spanning hundreds of thousands of years. The evidence for this precarious situation emerges from careful geological study of ash layers, radioactive dating of eruption deposits, and monitoring of current seismic activity, all of which suggest that the interval between major Yellowstone eruptions typically ranges between 600,000 and 800,000 years. Meaning we are currently residing in a window of geological time when such a catastrophic event is not merely possible, but has entered the realm of statistical inevitability on a timescale that, while perhaps not immediate in human terms, represents an overdue payment on a debt to nature's volatile processes. The psychological mechanism that allows us to maintain normalcy in the face of this reality involves a profound temporal disconnect, wherein our brains, evolved to process threats on scales of seconds to decades, struggle to internalize the significance of phenomena operating on timescales of hundreds of thousands of years, making the supervolcano threat feel abstract and theoretical rather than urgently real. Furthermore, we have normalized this danger through familiarity and invisibility, visiting Yellowstone as a tourist destination and marveling at its geysers without confronting the fact that we stand atop one of Earth's most destructive forces. And the scientific community's careful, measured communication about volcanic risk serves not to alarm but to reassure, creating a comfortable buffer between knowledge and emotional Beneath your feet, invisible and indifferent to human concern, Earth's magnetic field has spent billions of years protecting our planet from the relentless bombardment of solar radiation and cosmic particles that would otherwise strip away our atmosphere and sterilize the surface of all complex life. Yet this protective shield, which has guided compasses and migrating animals for millennia, is far from permanent or stable. Throughout Earth's history, the magnetic poles have reversed themselves hundreds of times, sometimes gradually over thousands of years and sometimes with startling abruptness, swapping their positions as if the entire planet had suddenly flipped its internal polarity. When this happens, the magnetic field does not simply reverse in one decisive moment, but rather weakens significantly during the transition, creating extended periods of vulnerability where the planet's protective barrier becomes riddled with gaps and weak points. During these reversals, the field's strength can drop to as little as 10% of its normal value, a catastrophic diminishment that would allow increased cosmic radiation and solar wind to penetrate deeper into our atmosphere than they normally could, potentially triggering auroras visible at the equator and bathing the upper atmosphere in particles that could affect weather patterns, airline operations, power grids, and satellite communications. The mechanism driving these reversals remains incompletely understood, arising from the chaotic turbulence of molten iron swirling in Earth's outer core, where tiny fluctuations in temperature and flow patterns can accumulate into massive magnetic instabilities that eventually reorganize the entire field. What troubles scientists most is that we have no reliable way to predict when the next reversal will occur or how quickly it might happen, and geological evidence suggests that the transition could be catastrophically rapid, potentially unfolding over. Consider the geological reality that Earth's climate has not remained static throughout its history, but instead has cycled through periods of extreme glaciation and relative warmth in patterns that repeat roughly every 100,000 years, a rhythm so vast and inhuman in its scale that it unfolds across timescales that dwarf human civilization itself. During these ice ages, massive continental glaciers thousands of feet thick advance southward from the poles, consuming landscapes, reshaping coastlines, and fundamentally altering the conditions under which life must persist. Yet these cataclysmic transformations occur so gradually that individual human observers would perceive nothing but ordinary seasonal variation. The mechanism behind these cycles involves subtle variations in Earth's orbital parameters and axial tilt, factors influenced by gravitational interactions with other planets, changes in solar radiation intensity, alterations in atmospheric greenhouse gas concentrations, and the complex feedback loops between ocean circulation, albedo effects from ice sheets themselves, and atmospheric composition. Creating a system of such interconnected complexity that predicting future ice ages becomes an exercise fraught with uncertainty. What is perhaps most unsettling about ice age cycles is that they represent a form of planetary-scale climate instability fundamentally woven into Earth's physical structure, one that has operated for millions of years with complete indifference to whether human beings existed or thrived upon the surface. We have normalized this reality by compartmentalizing it into academic disciplines, treating it as historical fact relevant only to paleontologists and climate scientists. Yet the data demonstrates that we currently occupy a brief interglacial period that will inevitably end, that the glaciers will advance again, that the conditions supporting modern agriculture and civilization will collapse under advance. In roughly 5 to 7 billion years, our sun will exhaust the hydrogen fuel that currently sustains its core, and when that moment arrives, it will undergo a transformation so profound that it will fundamentally remake the inner solar system itself. As the sun enters its red giant phase, its outer layers will expand outward at an accelerating rate, swallowing the orbits of Mercury and Venus entirely, and possibly consuming Earth as well, though some models suggest our planet might survive in a scorched outer shell of the enlarged star's atmosphere. The sun's diameter will increase to perhaps 200 times its current size, making it so vast that if you stood on what remains of Earth, the solar surface would dominate nearly half the sky, a bloated sphere of roiling plasma and nuclear fusion burning with the fury of a dying star. Before this happens, the sun's increasing luminosity over the coming billions of years will gradually heat Earth's atmosphere, evaporating the oceans, stripping away the protective magnetic field, and rendering the planet completely uninhabitable long before the actual expansion occurs. What makes this reality particularly difficult to contemplate is that we exist in a narrow window of cosmic time where we can observe and understand this process intellectually, yet remain powerless to prevent or significantly alter it, a condition that highlights humanity's fundamental vulnerability to forces operating on scales beyond our influence or intervention. We have normalized our ignorance of this future by compartmentalizing it into the realm of distant science fiction rather than accepted astronomical fact, telling ourselves that billions of years is effectively infinite, that it does not matter because no one alive today will witness it, and that our current problems deserve our attention far more than cosmic timescales can justify. In approximately 5 to 7 billion years, our sun will exhaust its core hydrogen supply and begin its inevitable transformation into a red giant, expanding outward until its outer atmosphere engulfs the orbits of Mercury, Venus, and most likely Earth itself. Though some calculations suggest our planet might survive in a scorched, lifeless state just beyond the expanding stellar envelope. During this process, the sun's luminosity will increase dramatically, raising surface temperatures on any remaining planets to levels that will vaporize oceans, incinerate the crust, and strip away atmospheres entirely, leaving behind only a charred cinder orbiting an incomprehensibly massive dying star. The mechanism behind this cosmic consumption is simply the fundamental physics of stellar evolution. As stars age, they must continuously generate energy through nuclear fusion to counteract gravitational collapse, and when hydrogen becomes scarce, the core contracts and heats until helium fusion begins, causing the star to swell to monstrous proportions and release energy in quantities we can barely conceptualize. What persists as a quiet, largely unexamined awareness in human consciousness is the acceptance that our entire world, our civilizations, our accumulated knowledge and experience, and every biological legacy we represent will ultimately be obliterated by an indifferent physical process that requires no malice or intention, only the operation of natural law. We have normalized this endpoint of Earth's story not through explicit acknowledgement, but through collective silence. We spend our days navigating immediate concerns, while the knowledge that our planet carries an expiration date exists as a subdued hum beneath our awareness, rarely surfacing into our thoughts yet always present, a mathematical certainty that renders all our struggles both profoundly meaningful in their immediacy and utterly insignificant in their ultimate duration. Every single day, our moon moves farther away from Earth, carrying with it the gravitational anchor that has shaped our planet's existence for billions of years. This migration occurs at a rate of approximately 3.8 centimeters annually, a measurement so small that human perception cannot detect it across a single lifetime, yet relentless in its cosmic inevitability. The mechanism driving this separation stems from the tidal friction between Earth and Moon, where the gravitational pull of our satellite creates bulges in Earth's oceans and crust. And as our planet rotates faster than the Moon orbits, these bulges are dragged slightly ahead, creating a gravitational torque that accelerates the Moon outward while simultaneously slowing Earth's rotation. Over the course of 4.5 billion years, this process has already moved the Moon from an orbital distance of merely 14,000 kilometers to its current position of 384,000 kilometers away. The psychological weight of this reality lies in the paradox of scale and insignificance. The process is so gradual that it exists entirely beyond our awareness, yet so absolute in its trajectory that no force in the observable universe can reverse or stop it. We have built an entire civilization under the Moon's current influence, with our tides, our calendars, our nocturnal ecosystems, and our cultural mythologies all calibrated to a lunar position that is fundamentally temporary. In perhaps 50 billion years, the Moon will have drifted so far that it will no longer appear as the luminous disk we know, and Earth's rotation will have synchronized with the Moon's orbit such that we will always see the same face of our satellite. We continue our daily routines, building structures meant to last centuries, establishing traditions meant to endure through generations, all while orbiting beneath a moon that is slowly, inexorably, leaving us behind. Imagine a world where the same face always stares at its parent star, where one hemisphere bakes in eternal daylight while the other freezes in permanent darkness, and the concept of a sunrise or sunset exists only in the fossil record of a planet that no longer experiences such things. This is the reality of tidal locking, a gravitational phenomenon that has claimed countless worlds throughout the universe and may claim countless more before the cosmos reaches its final state. When a celestial body orbits close enough to a massive star or planet, the gravitational pull on the near side becomes significantly stronger than the pull on the far side, creating a tidal force that gradually slows the body's rotation until it matches its orbital period exactly. Over millions of years, friction from internal heating and stress gradually removes all rotational momentum, leaving the world spinning at precisely the same rate it orbits, forever presenting one face to its stellar master. The mechanism is coldly mathematical and utterly indifferent to the presence or absence of life, yet the implications are staggering in their finality. Any world that drifts too close to its star through orbital decay will eventually become tidally locked, frozen in this gravitational embrace from which escape is impossible. What makes this reality particularly unsettling is that we now know tidal locking may be far more common than we once assumed, affecting not only distant exoplanets but potentially countless moons throughout our own solar system, worlds that orbit in silence with half their surface eternally scorched and half eternally frozen, their atmospheres either boiled away long ago or locked in strange, permanent circulation patterns between the light side and the dark. We have normalized this cosmic fate by treating it as merely another planetary characteristic, cataloging tidally locked worlds with the same clinical detachment we apply to any other celestial body. The Earth spins more slowly today than it did billions of years ago, and this deceleration is not some distant future concern, but an ongoing process happening right now, measurable and relentless, adding fractional seconds to our days in ways that most people will never consciously acknowledge or understand. When our planet first formed approximately 4.5 billion years ago, a single rotation took perhaps 6 hours, meaning ancient days were dramatically shorter, and the world spun with a fury that would have made the atmosphere itself unstable and chaotic. The primary culprit behind this gravitational theft is the Moon, our closest celestial companion, which exerts a tidal drag upon the oceans and crust through gravitational forces, essentially pulling at our planet's rotation like a brake applied to a spinning wheel, transferring the Earth's rotational energy into the Moon's orbital mechanics, causing our satellite to gradually spiral away from us at roughly 3.8 centimeters per year. This process is irreversible and inexorable, locked into the physics of orbital mechanics, and as the Moon recedes further into space, the effect will paradoxically slow even more because the gravitational interaction will weaken, but the fundamental trajectory remains unchanged and certain. We measure this slowdown in milliseconds, adding leap seconds to our atomic clocks every few years in what seems like a bureaucratic inconvenience, but actually represents our species' desperate attempt to keep synchronized time aligned with Earth's actual rotation, creating a strange dissonance between human timekeeping systems and planetary reality. The psychological impact of contemplating this phenomenon is peculiar because we live our entire lives within a time frame so compressed compared to geological scales that the slowing feels abstract and irrelevant. Yet it is absolutely real and irreversible, much like many of the universe's cruelest mechani. Every single day, the Earth spins on its axis while orbiting the Sun, yet the length of each day is not constant, and over millions of years, days have been gradually becoming longer in a process so slow that we cannot perceive it within the span of a human lifetime. Yet it is inexorably happening all around us at this very moment. The Moon, that distant celestial body that has orbited our planet for billions of years, exerts a gravitational pull on Earth's oceans and crust, creating tides that generate friction and drag against our planet's rotation, acting like an invisible brake that slowly decelerates the spin of our world. This tidal friction means that the Earth rotates a tiny fraction slower with each passing year, and when you multiply this minuscule change across millions of years, the result becomes profound and undeniable. Scientists have calculated that days are lengthening at a rate of roughly 1.7 milliseconds per century, and while this seems infinitesimal, the ancient geological record reveals that 300 million years ago, a single day on Earth lasted only about 23 hours. The psychological mechanism behind our indifference to this reality lies in the fundamental mismatch between geological time scales and human perception. For our brains evolved to process changes occurring across years or decades, not across millions of years, making the gradual extension of days feel entirely abstract and divorced from lived experience. We wake and sleep to rhythms that feel eternal and unchanging, yet we are passengers on a world that is imperceptibly winding down, spinning slower with each orbit, our days lengthening by imperceptible increments that accumulate silently beyond the reach of human awareness or concern. Imagine standing at the center of the Earth and looking up at the stars above the North Pole, watching as the entire celestial sphere slowly rotates around you in a great cosmic dance that takes 26,000 years to complete one full rotation. This is axial precession, a fundamental wobble in our planet's spin axis that causes the north and south poles to trace out a complete circle in the heavens with the patience of deep geological time. The Earth's axis is not fixed in space, as we intuitively believe when we look at maps and globes in classrooms, but rather it precesses like a spinning top that has been set gently off balance, wobbling in a slow and inevitable pattern that shifts which star marks true north across the millennia. This wobble means that the star Polaris, which we call the North Star today, will not remain the North Star forever. In 13,000 years, the bright star Vega will hold that position instead, and eventually Polaris will reclaim it in another 13,000 years, completing the grand precession cycle. The cause of this wobble lies in the gravitational tugging of the Moon and Sun on our planet's equatorial bulge, those extra miles of Earth that bulge outward at the equator due to our rotation, and this constant celestial gravitational dance gradually tips our axis in a slow conical motion through space. What makes this reality particularly unsettling to contemplate is that the civilizations which built monuments aligned to our current North Star will find those same monuments pointing toward different stars thousands of years hence, rendering their careful astronomical alignments obsolete without any choice or action on their part. We have normalized this precession by acknowledging it scientifically, yet most of us move through our lives with an unconscious assumption that the stars remain eternally fixed above our heads, that the pole star was always north and will always be north, that the universe. The planet's climate system, once operating within narrow and predictable boundaries for thousands of years, is now accelerating toward states that human civilization has never encountered, with average global temperatures rising at a rate faster than at any point in the past 10,000 years, triggering cascading disruptions across every ecosystem and weather pattern that agriculture and infrastructure were designed to depend upon. Hurricanes intensify with unprecedented fury, droughts transform fertile regions into dust bowls, wildfires consume entire forests in days rather than seasons, and sea levels creep upward with relentless inevitability, erasing coastlines where billions of people have built their homes and economies. The mechanism driving this transformation is deceptively simple. Industrial civilization has extracted and burned fossil fuels accumulated over hundreds of millions of years, releasing greenhouse gases that trap heat in the atmosphere faster than natural systems can absorb or equilibrate, creating a planetary fever with no immediate off switch. We understand the physics completely. We can calculate the consequences with precision. We possess the technological capacity to transition away from carbon-based energy systems, and yet the response remains fragmented, delayed, and insufficient, as though acknowledging the full scope of the crisis requires sacrifices that societies find psychologically intolerable. The normalization of climate chaos persists because the problem operates on scales that individual perception struggles to grasp. The changes happen incrementally enough that each year feels similar to the last, while simultaneously catastrophic enough that confronting them creates paralyzing dread. We have chosen, collectively and repeatedly, to treat a problem we fully understand as though it were still uncertain, maintaining the systems that created it because the alternative demands transformation so profound that it. Imagine a planetary thermostat that, once turned up past a certain point, cannot be turned back down by any force we might reasonably apply. A feedback loop so severe and self-perpetuating that the very act of warming the planet accelerates the warming itself in ways that become geometrically unstoppable. This is the concept of runaway greenhouse effect, a scenario where rising temperatures trigger mechanisms that release even more greenhouse gases, which warm the planet further, which then triggers more mechanisms, creating a cascade that continues regardless of whether humans stop emitting carbon tomorrow. The most terrifying aspect of this possibility is not that it could happen, but that scientists cannot definitively tell us where the tipping point lies or whether we have already passed it without fully realizing it. When Arctic permafrost melts, it releases methane trapped for thousands of years. When ocean temperatures rise, they release dissolved carbon dioxide that has been sequestered in the depths. When forests die from heat and drought, they transform from carbon sinks into carbon sources. When methane hydrates on the seafloor destabilize, they bubble into the atmosphere. Each of these processes exists today not as speculation, but as observable phenomena already occurring at measurable rates. The psychological mechanism that allows this threat to persist in our collective consciousness without proportional action relates to our difficulty understanding exponential processes and our tendency to assume that planetary systems possess the same resilience and self-correcting properties that we observe in smaller ecosystems. We tell ourselves that nature is adaptable, that life finds a way, that the Earth has recovered from worse, all statements that contain fragments of truth but ignore the timescale problem entirely. Beneath the thick clouds of Venus lies a world so hostile that no human has ever stood upon its surface, and likely none ever will. Yet this planet represents perhaps the most sobering warning about our own planetary future that exists within our solar system. The atmosphere of Venus is composed primarily of carbon dioxide with clouds of sulfuric acid, creating a greenhouse effect so extreme that surface temperatures reach approximately 470 degrees Celsius, hot enough to melt lead, while atmospheric pressures crush down at 92 times what we experience at sea level on Earth. The sun, which appears as a dim glow through the perpetual haze, hangs motionless in the Venusian sky due to the planet's incredibly slow rotation, meaning a single day on Venus lasts longer than its year, a peculiar cosmic irony that renders the concept of time itself almost meaningless. The psychological mechanism that makes Venus our future so unsettling is rooted in the uncomfortable recognition that Venus was not always this way, that billions of years ago it may have possessed liquid water on its surface and potentially habitable conditions, before a runaway greenhouse effect transformed it into this hellscape of unimaginable proportions. We understand the physics of how this happened. Solar radiation heated the planet, water evaporated, hydrogen escaped to space, and carbon dioxide accumulated in an ever-thickening atmosphere that trapped more and more heat in an irreversible spiral toward planetary sterilization. The terror lies not in Venus's current state, but in the terrible plausibility of similar transformation, in the recognition that Earth follows the same fundamental laws of planetary physics, that the greenhouse gases we pump into our atmosphere operate on the same principles that destroyed Venus. And yet we continue this trajectory as though the warning written across an entire dead world holds no relevance to our present choices. Consider the habitable zone, that delicate band of orbital space surrounding a star where liquid water might theoretically persist on a planet's surface, where life as we understand it might take root and flourish. We have identified this zone as a fundamental requirement for biological existence, a cosmic prerequisite that seems almost merciful in its specificity. Yet this zone is not eternal. Stars evolve across billions of years, gradually burning hotter and more intensely as they age, their cores fusing hydrogen into heavier elements with relentless efficiency. As a star brightens, its habitable zone drifts outward, moving farther from the stellar furnace, a slow migration that forces any orbiting worlds to either chase this receding safe space or fall into conditions unsuitable for life. Eventually, the habitable zone will move so far outward that planets once comfortably habitable will become frozen wastelands, their atmospheres potentially collapsing into frozen layers on the surface. Conversely, inner worlds will be consumed by increasing radiation and heat, their oceans evaporating into space, their atmospheres stripped away by stellar winds. The mechanism underlying this reality is purely physical. Stars are not static furnaces but dynamic processes of nuclear transformation, bound by the immutable laws of thermodynamics. A star has a finite lifespan measured in billions of years, and during that time it must inevitably change. What makes this truth particularly disquieting is that life on Earth exists within this temporary window, a circumstance we have not fully internalized despite understanding the science. We have normalized our own temporal existence within an ephemeral zone, continuing to plan for distant futures, to build civilizations intended to last millennia, while existing within a habitable band that will eventually cease to exist for our planet entirely. Imagine a star system where liquid water once pooled on the surface of a world, where the temperature was just right for chemistry to dance into something resembling life, where an entire biosphere might have emerged and flourished across continents and oceans. Now imagine that same star, slowly burning through its hydrogen reserves, growing hotter and more luminous with each passing million years, pushing that habitable zone, that narrow band of orbital distance where conditions remain temperate, outward into the cold darkness of space. The planet that once sat in perfect equilibrium, receiving just the right amount of stellar warmth, finds itself slowly roasting as its star enters middle age. Or consider the reverse scenario, where the star gradually dims over billions of years, the habitable zone creeping inward, leaving behind a frozen world where liquid water freezes solid and the chemistry of life becomes impossible. This is the fundamental instability of habitability itself. The conditions that allow for life are not fixed features of the cosmos, but rather fragile temporal windows that inevitably close. Stars are not constant companions, but evolving furnaces that transform themselves across cosmic timescales, and any world unlucky enough to harbor biology must ride a wave of changing conditions that grows increasingly difficult to survive. The psychological weight of this reality rests in the recognition that survival is not a stable achievement, but a temporary negotiation with an indifferent universe, and that even the most favorable circumstances contain within them the seeds of their own obsolescence. We have normalized the idea that planets exist in habitable zones as though these zones were permanent features, but they are not. They are moving targets, and everything within them is caught in slow motion toward uninhabitability. Every star that exists in the observable universe is locked within an inescapable arc of transformation, a predetermined trajectory from birth through a series of inexorable stages toward either collapse or dispersal, and no force in the cosmos possesses the capacity to arrest or significantly alter this process once it has begun. Stars are born from collapsing clouds of gas and dust, igniting through gravitational compression until nuclear fusion commences in their cores, and from that moment forward, they embark upon a one-directional journey whose destination is written into the fundamental laws of physics itself. A star spends the majority of its existence in a delicate equilibrium, where the outward pressure from thermonuclear reactions in its core precisely balances the inward crushing force of its own gravity, a state called the main sequence that can persist for billions of years. Yet even during this apparent stability, the star is inexorably consuming its finite fuel supply. With each passing moment, hydrogen fuses into helium and the composition of the stellar core slowly shifts. And as the fuel depletes, the star must inevitably evolve, expanding or contracting, brightening or dimming, until it exhausts its fuel completely and enters the final stages of its existence. The psychological weight of this reality emerges from recognizing that every single star, including our own sun, is locked within this predetermined evolutionary pathway with the same certainty that a river must flow downhill, and nothing in the universe can offer even temporary reprieve from this trajectory. We have normalized this cosmic inevitability by incorporating stellar evolution into our scientific models and educational frameworks, treating it as an accepted fact rather than contemplating the profound implications of a universe where even the largest, most seemingly permanent structures are bound by unalterable timescales. In approximately 5 billion years, our sun will exhaust the hydrogen fuel at its core and begin a transformation so profound that it will fundamentally alter everything we know about existence on Earth, a process called the red giant phase, where the star swells to an enormous size and consumes the inner planets in its expanding atmosphere. As the hydrogen depletes, the core contracts and heats up, eventually becoming hot enough to fuse helium into carbon and oxygen, and this new energy source causes the outer layers of the sun to expand outward at tremendous velocities, growing to roughly 200 times its current diameter and engulfing Mercury, Venus, and eventually Earth itself in a slow, deliberate consumption that will take millions of years. The mechanism behind this transformation lies in the fundamental physics of stellar evolution, where the balance between gravitational collapse pushing inward and radiation pressure pushing outward shifts fundamentally once the primary fuel source is exhausted, creating an instability that forces the star to seek new equilibrium through catastrophic expansion. What makes this reality particularly unsettling is how thoroughly normalized it has become in our scientific understanding, how we discuss the death of our planet and the incineration of all life with the same detached language we might use to describe the weather, accepting it as merely another chapter in cosmic history rather than confronting the absolute finality it represents. We have internalized this knowledge into a kind of philosophical resignation, understanding that our sun's life cycle is predetermined and that no human action or intervention will alter this trajectory. And somehow this deterministic certainty has paradoxically provided comfort, transforming an incomprehensible catastrophe into a scheduled event so distant that it requires no immediate emotional response or existential crisis, allowing us to continue our daily life. Picture the final fate of a star like our sun, a massive sphere of nuclear fusion that has burned steadily for billions of years, suddenly reaching the end of its existence. When such a star exhausts its hydrogen fuel, it expands into a red giant, shedding its outer layers into the surrounding void, and what remains is a white dwarf, a stellar corpse so dense that a teaspoon of its material would weigh as much as an elephant on Earth. This remnant is no longer a living furnace, but rather a slowly cooling sphere, a leftover core of carbon and oxygen atoms compressed so tightly by gravity that electron degeneracy pressure holds it against complete collapse, creating one of the most extreme objects in the cosmos. The white dwarf will continue to cool for trillions of years, gradually fading into darkness as it radiates its remaining heat into the infinite cold of space, becoming eventually a black dwarf, an object so cold and dim that it would be invisible to any observer. What makes this reality particularly unsettling is the recognition that this will be the ultimate destination of our own sun in roughly 5 billion years, transforming the luminous center of our solar system into an inert, slowly darkening remnant around which the blackened husks of Mercury and Venus will continue their eternal orbits. We tend to think of our sun as permanent and unchanging, a constant presence that has always been there and will always be there. Yet the physics is absolute and indifferent, and every fusion reaction in its core is incrementally bringing it closer to this inevitable white dwarf phase. Our entire history, every human civilization, every achievement and discovery, everything that will ever exist on Earth, will occur within a tiny fraction of our sun's total existence, and all of it will be rendered meaningless in the vast timeline leading toward that final cooling white dwarf state. Consider the fate of a planetary nebula, that delicate shell of luminous gas ejected from a dying star, expanding outward into the cosmic void at speeds sometimes exceeding 20 kilometers per second, slowly dissipating into the darkness from which it emerged. These structures, which we have named after planets simply because early astronomers mistook their appearance for distant worlds, are temporary monuments to stellar death, and they represent one of the universe's most profound forms of dispersal and loss. A star in its final stages swells and sheds its outer layers, creating these intricate patterns of ionized hydrogen and helium that glow faintly with the radiation of the exposed core within. And yet this glow is fundamentally temporary, a last gasp of visibility before the nebula expands to such thinness that it becomes virtually undetectable. The gas disperses into the interstellar medium at a rate that ensures the nebula will eventually fade from observation within perhaps 10 to 20,000 years, meaning that countless planetary nebulae we see today will have completely vanished long before humanity develops the technology to study them comprehensively. What strikes us most profoundly is the complete indifference of this process to observation or witness. The nebula disperses whether or not any conscious being observes its expansion, and this beautiful structure, which took millions of years to form and only moments to eject, will be scattered across light years of space until it becomes indistinguishable from background interstellar dust. We have normalized this cosmic impermanence by classifying these objects, cataloging them, and studying their properties. Yet this systematic approach cannot change the underlying reality that we are watching ordered structures inevitably return to chaos, that the very process of stellar death creates these visible monuments only to ensure their dissolution, and that the universe Consider the permanence you feel in your life right now, the solidity of the structures around you, the people you believe will always be there, the version of yourself you think is fixed and unchanging, and then consider that every single one of these things is actively deteriorating in ways both visible and invisible. The mountains that seem eternal are being worn down grain by grain, molecule by molecule, reduced by wind and water and time until they become dust. The stars that have burned for billions of years will eventually exhaust their fuel and collapse into darkness or explode into nothingness. The DNA in your cells, the very blueprint of your existence, is being copied with small errors each time it replicates, changing who you are incrementally until the person you are now becomes unrecognizable from the person you will become. Even the protons themselves, those fundamental building blocks of all matter, are theorized to decay over incomprehensibly vast timescales, suggesting that everything in the physical universe is on a trajectory toward entropy and dissolution. This is not a metaphorical or poetic observation, but a literal description of the thermodynamic reality in which we exist. Nothing in this universe has been granted exemption from change and degradation. The reason this persists as a realization we continuously forget is that human consciousness operates on timescales so small compared to cosmic ones that permanence feels like a reasonable assumption. We experience a single human lifetime, perhaps 80 or 90 years, and in that span many things do seem stable, which trains our minds to expect stability as the natural state. But this is a profound optical illusion, a trick played by the brevity of our perception against the vastness of time itself. Consider a perfectly organized room, a freshly painted house, or a newly formed star system, and imagine the inevitable march of time consuming each of these orderly arrangements with patient inevitability. Because entropy, that fundamental principle of thermodynamics, ensures that disorder always increases in any isolated system, meaning that every organized structure you encounter in the universe is fundamentally engaged in a slow, irreversible decay toward complete randomness and uniformity. When you burn a piece of wood, the carefully ordered chemical bonds holding the material together transform into ash, heat, and smoke that disperses into the air, spreading outward in all directions with no force capable of gathering those particles back together again. And this is not merely what happens to wood, but what must happen to everything, from the grandest galaxies to the smallest atoms within your body. The mechanism underlying this universal law operates through probability itself, because there are exponentially more ways for a system to be disordered than ordered, making disorder the natural resting state toward which all things inevitably drift when left to their own devices. Much like how a shuffled deck of cards is far more likely to remain shuffled than to spontaneously reorganize itself into perfect sequence. Yet despite understanding entropy scientifically, we construct elaborate systems of maintenance and energy expenditure to temporarily stave off this decay, building houses that require constant repair, maintaining our bodies through consuming food and expending effort, and creating societies dependent on continuous resource consumption just to maintain the illusion of order, all while knowing that every action we take to organize something merely increases entropy elsewhere. That the very act of preventing disorder in one place necessarily creates greater disorder in another. Everything in the universe is gradually moving toward disorder, toward entropy, toward a state of maximum randomness and heat death, and this law is so fundamentally woven into the fabric of reality that we cannot escape it, even in our most desperate aspirations for permanence. The second law of thermodynamics states that entropy in an isolated system always increases over time, meaning that every action we take, every structure we build, every order we create comes at the cost of creating even greater disorder elsewhere. And this creates a peculiar asymmetry in our universe where time itself has a direction, moving always from organized past to chaotic future. We can witness this principle manifesting in every moment of our existence. A hot cup of coffee cooling on a table, a pristine car rusting slowly in sunlight, our own bodies aging and breaking down despite our best efforts at maintenance, civilizations rising and falling, stars burning out their fuel, galaxies spinning into eventual darkness. The mechanism underlying this absolute law operates at the molecular level, where particles naturally distribute themselves into states of greater probability, where organized energy naturally disperses into heat, where the universe simply prefers to be messy rather than neat. What makes this reality particularly unsettling is that we have intellectually accepted this principle as immutable law, yet we continue to construct our lives, our hopes, and our civilizations around the implicit denial of it, building monuments we pretend will last forever, preserving things we know will inevitably decay, expending enormous effort to maintain order against a universe fundamentally opposed to our efforts. We have normalized this contradiction between what we know and what we do, between the absolute certainty of entropy and our elaborate systems of preservation, creating a strange acceptance of futility wrapped in the language of meaning and progress. Time moves in only one direction, from past to future, and we experience it as an irreversible flow where causes precede effects and entropy always increases. Yet the fundamental laws of physics contain no such directive, suggesting that at the deepest level of reality, time should be symmetrical and reversible, able to flow equally backward or forward without violating any known equations. When you observe a glass of water gradually warming to room temperature, the second law of thermodynamics tells you that the disorder in the system increases, creating an arrow pointing toward the future. But if you could rewind every atom and molecule to its exact previous position and velocity, the glass would cool back down, because the microscopic laws governing particle interactions work identically in both temporal directions. The arrow of time emerges not from physics itself, but from probability and statistics, from the astronomical improbability that randomly distributed particles would spontaneously arrange themselves into increasingly ordered states, meaning the arrow exists primarily in our experience of moving from low probability states to high probability states, from the organized past where few configurations were possible to the chaotic future where countless configurations become possible. Our memories only form in one direction because entropy increases, because the brain requires energy expenditure to store information, and this biological process itself obeys the same statistical gradient that governs the universe, creating a feedback loop where our consciousness experiences time as directional because our very capacity to be conscious depends on thermodynamic asymmetry. Yet we have normalized this profound asymmetry as obvious and natural, accepting that we remember the past but not the future, that we can influence what comes next but never what came before, despite the fact that nothing in the fundamental substrate of reality demands thigh. Consider the fundamental architecture of reality itself, where every system, no matter how carefully designed or theoretically perfect, eventually winds down into stillness. Perpetual motion machines have captured human imagination for centuries, representing an almost mythical desire to create something from nothing, to generate endless energy without any input or loss. Engineers and inventors throughout history have attempted to construct machines that would operate indefinitely without external energy sources, designing elaborate systems with perfectly balanced wheels, frictionless bearings, magnetic fields arranged in theoretical perfection, and mechanical configurations that seem to defy the inevitable. Yet each experiment, each blueprint, each carefully conceived prototype has inevitably failed, dissipating its energy into heat and disorder until the machine slows, stutters, and finally ceases. This is not merely engineering failure but a fundamental law written into the universe itself, the second law of thermodynamics, which states that entropy always increases, that disorder and heat loss are not flaws to be overcome but essential features of existence itself. The deeper tragedy lies not in the impossibility of perpetual motion, but in how this principle extends far beyond machines, affecting everything we create, maintain, and cherish. Relationships require constant energy input to prevent their decay into indifference. Civilizations must continually expend resources and effort to maintain themselves against collapse and fragmentation. Bodies age and deteriorate despite our best efforts at preservation. Even stars, those apparent eternal furnaces, burn through their fuel and eventually extinguish. Yet humanity continues to behave as though certain things might somehow escape this universal rule, investing hope in institutions that seem permanent, in love that feels infinite, in youth that feels like it might stretch forever. Consider the simple act of burning wood in a fireplace on a cold winter evening. The chemical bonds within the timber release enormous quantities of thermal energy that radiate outward into the room, warming your skin and the surrounding air with an almost tangible intensity. Yet within hours, that heat has dissipated entirely into the atmosphere, spreading thinly across the vast expanse of the planetary system until it becomes indistinguishable from the background temperature of the cosmos itself. This is not a temporary phenomenon or a reversible process, but rather the fundamental direction in which all energy in the universe inevitably moves. Every organized form of energy, the electricity powering your home, the chemical potential stored in food, the kinetic motion of falling water, the nuclear fusion burning within distant stars, follows this singular trajectory toward maximum entropy and disorder. The second law of thermodynamics dictates that energy cannot be destroyed, only transformed and dispersed into increasingly dilute and unusable forms. A car engine converts the concentrated chemical energy of gasoline into motion and heat, but most of that energy immediately radiates away as waste warmth that can never be recaptured or recollected into any useful form. Life itself represents a temporary pocket of organized energy and complexity, a localized resistance against this universal dissipation, yet we too are merely slowing an inevitable process that will eventually claim us entirely. Our bodies burn chemical fuel extracted from plants and animals, generating heat and consciousness and movement, only to have that energy inevitably leak away as thermal radiation and decomposition into the environment. This process is not accidental or correctable through human ingenuity or technological advancement, but rather the most fundamental law governing physical reality itself. Consider the paradox of entropy, that inexorable law which dictates that all ordered systems must inevitably tend toward disorder. Yet we live our entire lives constructing elaborate frameworks of organization as though we might somehow exempt ourselves from this universal rule. We build cities with precise geometric layouts. We establish governments with clearly defined hierarchies and procedures. We create systems of classification and categorization for everything from library books to biological specimens, all under the assumption that if we simply impose enough structure and maintain enough vigilance, we can preserve order indefinitely. Yet the moment we cease our efforts, the moment our attention lapses even slightly, these carefully constructed systems begin their inexorable descent into chaos. A garden left untended becomes overgrown within weeks. A building abandoned for years crumbles as if time itself is rushing to reclaim it. The psychological mechanism underlying this behavior appears rooted in our deep need to feel control over our environment, a sense that imposing order somehow protects us from randomness and mortality. We mistake the temporary stability we achieve through constant effort for something permanent, something almost sacred, when in reality we are simply holding back an ocean with our bare hands. What makes this particularly profound is that we have always known this truth intuitively, yet we continue to build and organize and structure anyway, not because we believe it will last forever, but because the act of creating order provides us a sense of purpose and meaning even in the face of inevitable decay. We have somehow normalized this Sisyphean struggle, treating it not as an absurd condition, but as simply the work of civilization itself, the natural price of existing as conscious beings aware of our own fragility. Consider the elaborate systems we have constructed throughout human civilization, the intricate networks of technology, governance, commerce, and knowledge that appear permanent and essential to our existence. And yet every single one of them exists only in a temporary state of organized complexity that is fundamentally opposed to the natural direction of entropy in the universe. Everything we have built, from the greatest cities to the smallest computer chip, from democratic institutions to scientific frameworks, represents a local and temporary reversal of entropy, a brief gathering of order in a universe that relentlessly pushes toward disorder and simplification. Our minds instinctively perceive these systems as stable and eternal because they persist across our individual lifespans. But on the scale of geological time, cosmic time, or even historical time measured in thousands of years, they are merely flickering moments of organization that will inevitably decay and dissolve. The complexity we have achieved is not a natural state, but rather an exhausting maintenance project that requires constant energy input, constant refinement, constant vigilance, and the moment we cease to pour our attention and resources into these systems, they begin their inexorable collapse back into simpler forms. We have normalized this temporary complexity as though it were permanent, building our entire psychological and social existence around the assumption that these intricate systems will remain coherent and functional. Yet we possess abundant historical evidence that complexity is fragile, that civilizations crumble, that technologies become obsolete, that knowledge systems are periodically overturned, and that what seems essential and permanent to one generation becomes archaeological curiosity to the next. Every piece of information you possess, every memory you hold, every digital file stored on your devices exists in a state of constant entropy. The moment a fact enters your mind or a photograph is saved to a hard drive, the degradation has already begun, a process as inevitable as rust-consuming metal or stone crumbling to dust. This degradation operates on multiple levels simultaneously. The physical medium deteriorates as magnetic fields weaken on old hard drives, paper yellows and becomes brittle, and the biological neural pathways that encode your memories gradually lose their fidelity with each passing year. Beyond the physical realm, information degrades through the simple passage of time and the corruption of context, as languages evolve and historical understanding shifts, rendering old texts ambiguous or incomprehensible to future generations. The precise details of events blur and compress in memory until only the emotional residue remains, a pale shadow of what actually occurred. Even in our supposed age of digital permanence, files become corrupted through bit rot, formats become obsolete and unreadable, servers fail catastrophically, and the metadata that gives information meaning disappears without warning. What makes this reality particularly unsettling is that we have built our entire civilization on the assumption that information can be preserved and transmitted with perfect clarity, yet nature itself seems fundamentally opposed to this goal. We continue to archive, document, and store information with meticulous care, desperately trying to outsmart entropy through redundancy and careful preservation, all while knowing at some deeper level that every backup will eventually fail, every record will eventually deteriorate, and every truth we attempt to lock away will ultimately dissolve into obscurity and distortion. Consider the strange tragedy of human memory, where the most significant moments of your life gradually dissolve into abstraction and shadow, becoming less vivid with each passing year until they are barely distinguishable from dreams or stories you once heard about someone else. That wedding day that consumed your thoughts for months, the birth of your child, the moment you learned someone had died, the faces of people you loved for decades, all of these experiences, no matter how profoundly they shaped you, will eventually lose their texture and specificity. You will struggle to recall the exact color of the sky, the precise tone of a voice, the specific words that were spoken, the intricate details that made the moment feel so absolutely real and present. The mechanisms behind this fading are rooted in the biological structure of how memory consolidates, how proteins decay, how neural pathways strengthen some connections while others atrophy from disuse, how each act of remembering actually reconstructs and slightly alters what you think you remember. Over time, emotional memories become emotional abstractions. You know something was sad or joyful, but the immediate sensation of that sadness or joy becomes inaccessible. Yet despite understanding this is an inevitable biological process, we continue living as though our memories will remain crystalline and permanent, trusting our recollections with confidence even as neuroscience demonstrates that memory is fundamentally unreliable and reconstructive. We document our lives obsessively through photographs and videos, attempting to create external anchors for experiences that will inevitably blur, and somehow this collective attempt to preserve the unpresentable speaks to our deep inability to accept that we are slowly forgetting the very people and moments that defined us. Every cell in your body contains billions of letters in your genetic code, and every time a cell divides to create new tissue, that code must be copied with near-perfect precision, yet this perfection is impossible to maintain indefinitely. Throughout your life, from the moment you were born until this very moment, Errors have been silently accumulating in your DNA, small mutations and copying mistakes that slip past the cellular machinery designed to catch them. And while most of these errors are harmless, some alter the way your cells function, change how proteins are made, or disable the safety systems that normally prevent cells from becoming cancerous. These mutations build up in your blood cells, your skin cells, your organs, and every other tissue, and the older you become, the more of these errors you carry, until eventually the sheer number of accumulated mistakes becomes a liability that your body can no longer manage effectively. The reason this happens is both elegant and terrifying. DNA replication enzymes are extraordinarily accurate, catching and correcting most mistakes before they become permanent, but they are not perfect, and they cannot catch everything, and some mutations slip through because they occurred in regions of the genome that are harder to repair or in patterns that the error-checking system cannot recognize. What makes this process feel particularly dark is that we have normalized it completely, treating aging and disease as inevitable consequences of living rather than what they fundamentally are. The accumulation of cellular damage that compounds over time, damage that could theoretically be slowed or prevented, but which we accept as the price of existence. We do not dwell on the fact that every birthday brings not only celebration, but also thousands of new mutations that might one day become serious, that your cells are slowly becoming stranger versions of themselves, accumulating the very errors that coup. Within your body right now, billions of your cells are quietly entering a state of irreversible stillness, a biological limbo where they can no longer divide or replicate but refuse to die, accumulating in tissues and organs like worn machinery that no longer functions yet remains impossibly present. This process, called cellular senescence, represents one of the most profound paradoxes of human existence, where the very cells that comprise you become trapped in a state of perpetual stasis, continuing to exist while slowly poisoning the environment around them through the release of inflammatory compounds and degraded proteins. Each time a cell divides, the protective caps at the ends of your chromosomes, called telomeres, grow shorter, and after approximately 50 to 70 divisions, these telomeres become so brief that the cell receives a biological signal to stop replicating entirely, entering senescence as a defense mechanism against cancer. Yet in doing so, these senescent cells accumulate like unremoved debris, triggering chronic inflammation throughout your body that accelerates aging, weakens your immune system, and contributes to virtually every age-related disease that eventually kills you. The cruelest aspect of this system is that senescence was designed to protect you, to prevent cells from becoming cancerous by refusing them the ability to divide endlessly. Yet this protection becomes your undoing as decades pass and millions of these dead but living cells remain embedded in your tissues, their inflammatory secretions creating an environment of perpetual low-grade damage that your younger self never experiences. We have accepted this as simply the nature of aging, as though there exists no alternative, and in our acceptance, we have normalized the idea that our own bodies are slowly poisoning themselves from within, that the very cells meant to keep us alive become agents of our gradual deterioration, a mechanism so fundamental. Every second that passes is a second you will never get back, and with each moment your body moves further away from its peak function, closer to the inevitable decline that defines the human condition. Your cells divide and replicate thousands of times throughout your life, and with each division, the telomeres at the ends of your chromosomes shorten, like a biological clock counting down toward dysfunction. Collagen breaks down in your skin, elasticity fades, bones lose density, muscles atrophy without constant effort, and the neural pathways in your brain become less efficient at forming new connections. Gray hairs appear not because of stress or lifestyle choices, but because your body literally stops producing the pigment that once colored them, a visible marker of systems failing at the cellular level. You will watch yourself change in the mirror year after year, as gravity pulls everything downward, as lines deepen into permanent fixtures on your face, as your hands begin to show the liver spots and wrinkles that announce to the world that you are aging. The mechanism is simple and unavoidable. Entropy demands that all ordered systems eventually decay, and your body is no exception to this fundamental law of physics and biology. Your immune system weakens, your metabolism slows, your vision dims, your hearing fades, and the body that once felt invincible becomes increasingly fragile and prone to illness. Yet despite understanding this reality completely, despite knowing with absolute certainty that aging is happening to us right now in this very moment, we continue to live as though we have infinite time ahead of us. We normalize this slow dissolution by calling it natural, by accepting it as the price of life, by pretending that skincare products and supplements and exercise routines might somehow halt a process that is literally written into our genetic code. Consider that every living system, from the smallest bacterium to the largest whale, exists in direct violation of entropy's relentless march toward disorder, yet this violation carries within it the seeds of its own inevitable dissolution. Life maintains its improbable organization through constant energy expenditure, through the burning of resources and the generation of waste, and this process of staying alive paradoxically generates the very conditions that guarantee eventual failure and cessation. Every heartbeat, every thought, every breath you take generates entropy not just within your body but around it, pushing the universe ever closer to its final state of maximum disorder. And in doing so, you are simultaneously building the thermodynamic debt that your own death will eventually help to pay. The second law of thermodynamics does not merely describe physical systems in abstract terms. It writes the obituary of every conscious being that has ever existed or ever will exist, embedding death not as a biological accident or an evolutionary oversight, but as a mathematical necessity woven into the fabric of reality itself. Your cells cannot replicate indefinitely without accumulating errors. Your telomeres cannot regenerate forever without eventually reaching their limit, and the energy gradients that your body depends upon cannot sustain themselves against the universe's inexorable tendency toward equilibrium. What appears to us as aging and disease and the slow approach of mortality is simply thermodynamics playing out at the biological scale, the same force that causes hot objects to cool and organized systems to decay now operating on the substrate of your flesh. We have learned to call this natural law, to accept it as inevitable, to structure our entire civilization around the acknowledgement that all things must end, yet we remain psychologically unprepared for its application to ourselves, as though understanding th. Consider that the very awareness you possess right now, the sense of self that reads these words and experiences this moment, will eventually cease entirely. Unlike a pause or a sleep from which you will awaken, consciousness as you know it will simply end, and there will be no you to observe that ending or mourn it. This is not metaphorical or spiritual speculation, but a biological certainty that science confirms with each passing year. Your consciousness, that luminous thread of awareness that seems so fundamental to your existence, is actually a temporary phenomenon generated by a physical system that will inevitably fail. The brain that produces your thoughts, your sense of identity, your memories, and your perception of the world is a fragile organ composed of approximately 86 billion neurons held together by electrochemical processes that depend entirely on continuous blood flow and metabolic function. When that system stops, consciousness stops with it, as completely and suddenly as a light switch being turned off. The mechanism behind this reality is straightforward yet profound. Consciousness appears to be an emergent property of neural activity, arising from the coordinated firing of neurons in complex patterns that somehow generate the subjective experience of being alive and aware. There is no separate essence, no soul or spirit that persists independently of this physical substrate. Damage to the brain damages consciousness. Destroy the brain entirely and consciousness is extinguished. Yet despite the overwhelming evidence for this temporary nature of awareness, humans have developed elaborate psychological frameworks to deny or obscure this reality. Religions promise eternal souls, philosophies suggest consciousness continues in some form, and our daily preoccupations distract us from contemplating the impermanence of our own mind. Consider the simple fact that your brain is deteriorating from this very moment forward, a gradual and inexorable process that began the instant you were born, accelerating with each passing year until the day you die. Every neuron in your cerebral cortex is slowly losing its connections, its ability to fire with precision, its capacity to retain information with the clarity it once possessed. Memory gaps appear where there were none before, and you rationalize them as mere forgetfulness, as if the mind were simply a filing cabinet occasionally misfiling documents rather than an organ actively degrading at the cellular level. The proteins that maintain synaptic health accumulate in misfolded tangles and plaques, the mitochondria that power neural computation sputter and fail, and the glial cells that support and nourish neurons become increasingly inefficient with time. This process happens silently, without sensation or warning, which perhaps explains why we have developed such a remarkable capacity to ignore it entirely. We notice the external signs, the slight difficulty recalling a name, the momentary blank when searching for a word, the increasing reliance on written reminders, yet we treat these symptoms as trivial inconveniences rather than harbingers of deeper structural collapse. The brain has no pain receptors, which means neural decay produces no suffering until it becomes severe enough to genuinely impair function, allowing us to spend decades unaware that the very organ generating our consciousness is slowly coming undone. We have normalized this reality so thoroughly that we call it simply aging, as though assigning it a mundane name somehow renders it less profound, less unsettling, less catastrophic to contemplate. Yet in this acceptance of decline lies a peculiar mercy. The same deteriorating brain that cannot remember yesterday's conversation is equally incapable of fully grasping the magnitude of its own dissolution, sparing us tea. Your brain, the most complex object known to exist in the universe, is fundamentally designed to deteriorate. Every moment you are alive, the neural pathways that compose your thoughts, memories, and sense of self are experiencing entropy, a gradual increase in disorder that cannot be reversed or stopped, only delayed through the expenditure of tremendous biological energy. The neurons that fire in your brain generate heat as a byproduct, which represents energy leaving your system in its most disordered form, and with each thought you have, with each memory you consolidate, you are creating irreversible disorder in the physical substrate of your consciousness. Your brain must constantly work against this natural tendency toward chaos, using glucose and oxygen to maintain the precise electrochemical gradients that allow thought to occur, and the moment this energy supply is interrupted even briefly, the entropy that has been held at bay begins to win. What makes this reality particularly unsettling is that your subjective experience of having a coherent identity, of being a unified self that persists through time, is actually a temporary island of order in a universe fundamentally committed to disorder. And the very act of maintaining that sense of self requires your brain to burn through resources in a losing battle against entropy itself. You cannot think without generating disorder, you cannot remember without creating heat death on a microscopic scale, and you cannot be conscious without participating in the universe's relentless march toward maximum entropy. We have normalized this existential trap by simply not thinking about it, by treating consciousness as somehow exempt from the laws of thermodynamics when it is perhaps the most direct expression of those laws, a temporary eddy in the cosmic current that must eventually dissolve back into the void. In the realm of quantum mechanics, there exists a phenomenon so fundamental yet so unsettling that it strikes at the very heart of reality itself, and that phenomenon is known as quantum decoherence, which describes the process by which a quantum system loses its coherence and transitions from existing in a superposition of multiple states into a single, definite classical state that we can observe and measure in the everyday world. When a quantum particle exists in superposition, it simultaneously occupies multiple states at once, existing in a kind of probabilistic fog where all possibilities coexist in an elegant mathematical dance. But the moment an external observer or environmental influence interacts with that system, the delicate quantum state collapses irreversibly into one concrete outcome. And this collapse happens not through some mystical conscious observation, but through the inevitable entanglement of the quantum system with its environment, a process so relentless and unavoidable that isolated quantum states simply cannot persist for more than infinitesimal fractions of a second before decaying into classical reality. The mechanism behind this dissolution is both elegant and terrifying. Every quantum system is bombarded constantly by photons, particles, electromagnetic radiation, and thermal energy from its surroundings, and each of these interactions causes the system to lose information about its quantum nature, scattering that information irretrievably into the environment in a way that makes it impossible to ever reconstruct the original superposition state. Which means that the universe itself seems designed to erase quantum possibility the moment it threatens to become real. What haunts us most profoundly about decoherence is that it reveals the universe to be fundamentally hostile to complexity and superposition, systematically destroying any chance that multiple realities could coexist simultaneously in our observable. Consider the unsettling reality that exists at the foundation of quantum mechanics, where the universe appears to operate according to two entirely different sets of rules, depending on whether we are observing it or not. Before measurement, a particle exists in what physicists call a superposition, a strange state where it simultaneously occupies multiple positions and possesses multiple properties at once, described mathematically by something called a wave function that encompasses all possible states the particle could be in. The moment an observer measures or observes this particle, something extraordinary and deeply troubling occurs. The wave function collapses instantaneously, and the particle suddenly snaps into a single definite state, selecting one of those many possible outcomes, as though the act of observation itself forces reality to make a choice. This phenomenon, known as wave function collapse, suggests that the universe does not have definite properties until consciousness or measurement forces it to crystallize into being, implying that observation literally creates reality rather than simply revealing what already exists. What makes this conceptually vertiginous is that no one truly understands why this happens or what mechanism enables it. Physicists can calculate when collapse will occur with remarkable precision, yet they cannot explain the underlying reason for this strange quantum theater. The Copenhagen interpretation, which most introductory physics courses teach, simply accepts this mystery as fundamental to how nature works, treating the observer and the observed as mysteriously entangled in ways that seem to violate the classical separation between subject and object. Some physicists have proposed alternative explanations such as many-worlds theory, where collapse does not occur and instead all possible outcomes happen in branching universes, or objective collapse theories where the wave function crumbles due to. At the quantum level, there exists a fundamental constraint woven into the fabric of reality itself, one that Heisenberg discovered in the early 20th century, which stipulates that you cannot simultaneously know both the position and momentum of a particle with perfect precision, and the more accurately you measure one property, the less accurately you can know the other, creating an inherent fuzziness at the heart of existence that no amount of technological advancement or experimental refinement can ever overcome. This is not merely a limitation of our current instruments or methods, but rather a mathematical truth embedded in the wave function itself, suggesting that nature operates with an irreducible uncertainty that cannot be eliminated or circumvented through any means whatsoever. The reason this persists is fundamentally mechanical. The act of observation itself, the very process required to gather information about a quantum system, necessarily disturbs that system in ways that are impossible to isolate or control, meaning that the universe does not contain definite values for all properties at all times, but rather exists in a state of probabilistic superposition where multiple potential outcomes coexist until the moment of measurement collapses them into a single reality. This strange duality extends beyond physics into philosophy and epistemology, for it suggests that complete knowledge of any system is not merely practically difficult but theoretically impossible, that there exists a permanent blind spot in our ability to understand reality at its most fundamental level, and we have normalized this cosmic indeterminacy by building it into our theories, our models, and our expectations about how the universe actually functions. Accepting that the deepest truths of existence operate according to chance and probability rather than deterministic certainty, a realization that undermines classical intuitions about how nature shows. Consider the finite nature of human consciousness and the infinite expanse of what exists to be known, a chasm so vast that it renders the pursuit of complete understanding not merely difficult but fundamentally impossible. And yet we continue through our lives operating under the illusion that such knowledge might one day be within our grasp if we simply study hard enough, read enough books, or accumulate enough experience and credentials. The universe contains countless galaxies, each holding billions of stars, and around those stars orbit planets with ecosystems so complex that a single square meter of soil contains more organisms than there are human beings alive, each with their own biological intricacies and behavioral patterns that remain largely mysterious even to our most dedicated scientists. Beyond the visible realm lie quantum phenomena that seem to operate under rules that contradict our everyday experience, dark matter and dark energy comprising 95% of the cosmos, yet remaining almost entirely unknown to us, and theoretical dimensions beyond our perception that mathematics suggests might exist, but that our senses will never directly access. The human brain itself, that organ responsible for all knowledge acquisition, contains approximately 86 billion neurons with trillions of connections, yet we understand only a fraction of how consciousness actually emerges from this biological machinery, how memories are truly formed and stored, or why we dream the way we do. The mechanism underlying this limitation is not a failing of effort, but rather a fundamental logical boundary. Any system attempting to fully understand itself encounters recursive problems that cannot be resolved, for to know everything would require the knower to step outside themselves to observe and comprehend their own process of knowing, creating an infinite regression. In the quantum realm, there exists a principle so deeply unsettling that it fundamentally challenges our understanding of what reality actually is. And this principle suggests that the act of observing something inherently changes its nature before we can ever truly know it. When physicists attempt to measure the position of an electron, they must use photons of light to detect it, and in doing so, they inevitably transfer energy to that electron, altering its momentum in ways that make it impossible to know both its position and velocity simultaneously with perfect precision. This is not merely a limitation of our instruments or our current technology, but rather a fundamental feature woven into the fabric of existence itself, suggesting that observation and reality are not separate concepts, but deeply intertwined phenomena. The universe does not exist in a definite state waiting for us to discover it, but rather seems to exist in a superposition of all possible states until the moment we choose to measure it, at which point it collapses into one particular reality. This phenomenon extends beyond the quantum scale in subtle but profound ways, manifesting in how our attention shapes our perception of the world around us, how the act of studying human behavior changes that behavior, and how measuring economic variables influences those very variables in ways that create feedback loops we cannot escape. We live in a reality where the observer cannot be separated from the observed, where consciousness or measurement itself plays an active role in determining what is real, and where the universe seems almost to resist our attempts to pin down absolute truths. Yet despite the revolutionary implications of this understanding, we continue to live as though the world exists independently of our observation, as though reality is fixed and waiting rather than fluid and responsive to our attention. Consider the unsettling notion that reality itself might not exist in any definite state until someone observes it, a principle discovered at the quantum level that challenges our most fundamental assumptions about an independent universe existing whether or not we are here to witness it. When physicists examine subatomic particles, they find that these entities exist in a superposition of multiple states simultaneously, occupying all possible conditions at once in a kind of quantum limbo, until the precise moment a measurement occurs and forces the particle to collapse into a single, definite reality. The act of observation itself, the very process of trying to detect what something is doing, fundamentally alters what that something becomes, which means the observer and the observed are not separate entities, but are inextricably entangled in a dance of mutual creation. This principle, validated repeatedly through rigorous experimentation over decades, suggests that consciousness, or at least the act of measurement, plays a role in bringing reality into being, transforming potential into actual. And this raises the profoundly disturbing question of what the universe was doing before conscious observers evolved to look at it. We have normalized this contradiction by compartmentalizing it, treating quantum mechanics as a mathematical tool that works for calculations without fully confronting what it implies about the nature of existence itself. And we tell ourselves that observation merely reveals what was always there, even though the mathematics plainly shows that nothing was definitively there until observed. The persistence of this cognitive dissonance reflects our deep need to believe in an objective world independent of our minds, a comfortable assumption that allows us to function without constant existential vertigo. Yet the universe appears fundamentally indifferent to our psychological comfort and continues operating according to rules. Consider the simple act of observing a sunset. You perceive it as beautiful, warm, and calming, while another person standing beside you might experience the same photons of light reaching their retinas as melancholic, oppressive, or entirely unremarkable. The sunset itself exists as electromagnetic radiation and atmospheric particles, but the experience of that sunset, the reality of it as you know it, exists only in the interpretation of your consciousness. This fundamental fracture between the physical world and conscious experience reveals something deeply unsettling. There may be no objective reality that exists independent of observation and interpretation. Physics has long suggested this through quantum mechanics, where particles behave differently when measured than when unobserved, as though reality itself waits for a witness before committing to existence. But the problem extends far beyond subatomic particles into every aspect of your lived experience. Two people witnessing the same historical event will construct entirely different narratives about what occurred based on their beliefs, memories, and the frameworks through which they interpret information. Your sense of time, space, color, and meaning are all constructed by your nervous system in ways that may bear only a passing resemblance to what exists independently. The mechanism behind this is the simple fact that you do not directly perceive reality. You perceive neural representations of reality created by your brain. Everything you believe you see, hear, taste, smell, and feel is actually your brain's best guess about external stimuli, a model rather than the thing itself. This should be deeply troubling, yet most people move through life assuming their perception reflects objective truth. Consider two events occurring at distant locations in the universe, events that seem to happen at exactly the same moment in time, yet Einstein's theory of special relativity reveals a troubling truth. There is no absolute present moment that applies across all observers, and what appears simultaneous to you may not be simultaneous to someone moving at a different velocity relative to you. Imagine two lightning bolts striking the ends of a train car at precisely the same instant according to an observer standing beside the tracks. Yet a passenger traveling inside that train at near light speed would perceive these events occurring in a different sequence, one flash reaching them before the other despite the physical reality being identical. This is not a matter of perception or measurement error, but rather a fundamental property of spacetime itself, woven into the fabric of reality at the deepest level. The mechanism behind this unsettling phenomenon emerges from the constancy of light speed regardless of the observer's motion, a bedrock principle that forces us to abandon our intuitive notion that time flows uniformly and universally for all observers everywhere. When two observers move relative to one another, they do not share the same reference frame, and the synchronization of clocks that seemed reliable in our everyday experience breaks down entirely at cosmic scales, revealing that the order of distant events becomes frame-dependent and malleable. What makes this particularly disquieting is that we have largely accepted this as normal scientific knowledge, filing it away as a curious mathematical quirk of physics rather than confronting what it truly means. The universe does not provide us with a single, objective timeline that encompasses all of reality simultaneously, and our sense that the present moment is universal and absolute is merely a parochial human illusion born from our sluggish, low-velocity existence on the SU. Imagine standing at the edge of a black hole while your friend remains safely on a distant planet, and though you both experience time passing normally within your own frames of reference, the friend watching you from afar sees your clock ticking slower and slower as you drift closer to that gravitational abyss, until from their perspective your movements become nearly frozen, your aging process stretched across centuries. While you yourself feel nothing unusual at all and continue living at what seems like a normal pace within your own subjective experience. This is time dilation, one of the most unsettling consequences of Einstein's theory of relativity, a phenomenon that reveals time is not the universal constant we intuitively believe it to be, but rather a flexible dimension that bends and warps depending on gravity and velocity. The mechanism behind this dark reality emerges from the fundamental nature of spacetime itself, where massive objects curve the fabric around them, and this curvature actually slows down the passage of time in regions of stronger gravitational pull, meaning time literally moves at different speeds in different places throughout the universe. What makes this particularly haunting is that this is not theoretical speculation or mathematical abstraction, but an observed and measured phenomenon that has been confirmed countless times through atomic clocks on airplanes, satellites in orbit, and our understanding of how neutron stars and black holes function. We have normalized this impossibility so thoroughly that it now serves as the foundation for technology we depend upon daily, from the precise timing required for GPS satellites to function correctly to our calculations about the ultimate fate of matter near event horizons. Yet the fundamental truth remains deeply strange. Time is not flowing uniformly around you right now. It is flowing at subtly different rates depending on your elevation, your speed, and the gravitati. As objects accelerate through space at velocities approaching the speed of light, something profoundly unsettling occurs to their physical dimensions along the direction of motion, a phenomenon known as length contraction, where the measured length of a moving object becomes shorter relative to a stationary observer, compressing inward as though the universe itself were squeezing the fabric of reality to maintain the cosmic speed limit that Einstein's relativity established as an absolute boundary. The effect emerges not from any physical force deforming the object, but rather from the fundamental nature of spacetime itself, where time and space are woven together so intricately that when an object moves faster, its journey through space necessarily compresses its spatial extent, a mathematical consequence that follows inevitably from the constancy of light speed across all reference frames. At everyday speeds, this contraction remains utterly imperceptible, barely affecting even objects traveling at the fastest velocities humanity has achieved. Yet as velocities approach 99% of light speed, the contraction becomes severe and dramatic, squeezing an object to mere fractions of its rest length, while observers aboard the moving object perceive nothing amiss, experiencing their surroundings as perfectly normal and uncompressed. What haunts the contemplation of length contraction is the revelation that there exists no objective length to anything in the universe, no fixed dimension that remains true across all perspectives, only relative measurements that shift and change based on the observer's motion and position in spacetime. The psychological weight of this realization settles slowly as one understands that the very solidity and dimension of physical objects dissolve into observer-dependent constructs, that a starship approaching Earth at relativistic speeds would appear crushed and flattened to observers below while they travel. Imagine that everything you see around you, every solid object, every person, every mountain and ocean, contains within it an almost incomprehensible reservoir of pure energy waiting silently beneath the surface, locked away by the fundamental laws of physics in a relationship so elegant and terrifying that it defies casual understanding. This is the reality of mass-energy equivalence, the principle discovered by Einstein that reveals matter and energy are not separate phenomena, but rather different expressions of the same underlying substance, convertible into one another according to the equation E=mc², where even a tiny amount of mass contains an enormous quantity of energy by virtue of the speed of light being such a fantastically large number. When you hold a penny in your hand, you are holding an object that contains roughly the same energy as several atomic bombs, an almost unimaginable force compressed into something so mundane and harmless that children play with it without hesitation. The psychological mechanism by which we accept this contradiction relies on the fact that this equivalence is not easily accessible, that converting mass to energy requires conditions so extreme or processes so rare in our everyday experience that we never actually witness it, allowing us to live in a comfortable compartmentalization where solid matter feels stable and inert, while nuclear reactions and particle collisions exist in a realm separate from ordinary experience. We have normalized this cognitive dissonance through decades of scientific education and cultural absorption, treating Einstein's revelation as an abstract truth rather than a visceral reality. So thoroughly have we insulated ourselves from the implications that we can learn about the destructive power of nuclear weapons or the energy production of stars, without truly internalizing that the same principle of mass energy conversion is occurring in every chemical. Everything you perceive as solid, tangible, and real is fundamentally not what it appears to be, and this truth sits quietly beneath every waking moment of human existence. The chair you sit upon, the ground beneath your feet, the flesh and bone that compose your body, are all manifestations of energy in its most condensed form, transformed by Einstein's elegant equation into a state so dense that it mimics solidity. At the quantum level, what we call matter is actually vibrating fields of energy, held together by invisible forces, constantly exchanging particles in a dance so intricate and continuous that the distinction between energy and matter becomes merely a matter of perspective and measurement. The atoms comprising your physical form are themselves mostly empty space, with electrons orbiting nuclei at incomprehensible speeds, yet this emptiness creates the illusion of weight and substance that defines your entire sensory experience of reality. This transformation of energy into matter is not a permanent state, but rather a temporary configuration, a brief crystallization of force into form, which means that you yourself are not a stable entity, but rather a constantly shifting arrangement of primordial energy masquerading as something fixed and unchanging. The mechanism that sustains this deception lies in the limitations of human perception, which evolved to detect only those frequencies and scales relevant to survival in our particular environment. Your brain interprets the electromagnetic interactions between atoms as the sensation of touching something solid, yet nothing actually touches anything else. Instead, forces repel forces, and your nervous system translates this quantum-level repulsion into the subjective feeling of contact. Over countless generations, we have built an entire civilization upon the foundation of this perceptual illusion, constructing physics, engineering, and architecture based on treating matter as fundament. Consider the fundamental nature of matter itself, the very substance that comprises your body, the ground beneath you, and every object you have ever touched or seen throughout your entire existence. Physics reveals to us that atoms, these supposedly solid building blocks of reality, are in fact vastly empty spaces, with their electrons orbiting at such distances from the nucleus that the atom is more void than substance, more absence than presence. The nucleus itself occupies only a tiny fraction of the atomic space, perhaps 100,000 times smaller than the electron clouds surrounding it. And if you were to scale up an atom to the size of a cathedral, the nucleus would be no larger than a grain of sand sitting somewhere within that massive empty space. This means that the chair you are sitting on right now, the bed beneath you, the walls of your room, and indeed your own flesh and bones are composed predominantly of empty space held together only by electromagnetic forces, by invisible attractions between particles that never actually touch one another. When two objects collide, they do not actually make contact at all. Rather, their electron clouds repel each other, pushing against an emptiness that pretends to be solid. The persistence of this bizarre reality exists because our sensory apparatus and cognitive systems evolved to perceive solidity as a useful operational fiction, rather than as an accurate representation of what exists at the subatomic level. We experience hardness, density, and substance because the repulsive electromagnetic forces are extraordinarily strong at the scales where we interact with objects, creating what feels like impenetrable surfaces even though we are fundamentally pressing emptiness against emptiness. Yet we continue to move through the world, constructing buildings and holding objects and resting our weight on chairs, behaving as though these things are solid despite knowing with absolute certainty. Consider for a moment the fundamental nature of matter itself, the very substance that comprises your body, the ground beneath you, and every object you have ever touched throughout your entire existence. At the quantum scale, where electrons orbit atomic nuclei, reality does not work the way your intuition suggests it should. An electron does not occupy a specific, definite location in space the way a marble sits in a particular spot on a table. Instead, an electron exists as a probability cloud, a mathematical distribution that describes where the electron might be found if you were to measure it. This cloud has no hard boundary, no clear edge where the electron definitely ends and empty space begins. The electron is simultaneously everywhere and nowhere within this cloud until the moment of observation collapses this wave function into a single location. This means that the atoms making up your hand, right now as you read these words, do not have sharp, well-defined edges at all. Your hand blurs into the air around it in a quantum sense. The boundary between you and the rest of the universe is not a clear line, but rather a probabilistic gradient that fades gradually outward. We have normalized this unsettling truth so completely that we do not feel the existential vertigo it should inspire. We teach it in schools as though it were merely another fact to memorize, no different from remembering historical dates or chemical formulas. Yet this represents perhaps the most profound strangeness available to human understanding. The very substance of your being is not solid in any classical sense. You are mostly probability, mostly the likelihood that matter exists in a particular region rather than matter that definitely exists. This dissolution of the boundary between particle and wave, between existence and potential, between the concrete and the uncertain, remains the central mystery of physics, and you walk through your day complete. Consider a particle trapped behind an energy barrier that, by all classical laws of physics, it should never be able to cross, yet somehow it does, appearing on the other side as if the barrier had never existed at all. This phenomenon, known as quantum tunneling, represents one of the most unsettling violations of the deterministic world we assume ourselves to inhabit. At the quantum scale, particles like electrons and photons demonstrate the capacity to pass through solid barriers that should require more energy to overcome than they actually possess, a feat that remains impossible in the macroscopic world where we conduct our daily lives. The mathematical framework of quantum mechanics tells us that particles don't have definite positions, but rather exist as probability waves, and these probability waves can extend through barriers, creating a finite chance that a particle will be found on the opposite side despite no classical path existing to get there. This means that the very atoms and molecules comprising your body are constantly tunneling through each other at infinitesimal scales, that the sun's fusion reactions occur only because hydrogen nuclei can tunnel through the electromagnetic repulsion that should keep them apart, and that the semiconductor devices powering modern civilization function only because electrons tunnel through insulating layers they shouldn't be able to penetrate. The psychological weight of quantum tunneling lies not merely in its counterintuitiveness, but in its fundamental challenge to causality itself, suggesting that particles need not follow any deterministic path and that barriers are merely statistical probabilities rather than absolute boundaries. We have normalized this dark reality by abstracting it into mathematics, by confining it to laboratory settings and theoretical discussions, by treating it as merely one layer of reality that doesn't affect our macroscopic experience, yet the universe persists. Deep within the quantum vacuum, at scales so infinitesimally small that they exist beyond direct observation, particles are constantly being born and dying in pairs, flickering in and out of existence in timeframes so brief that the universe's fundamental laws technically permit them to violate energy conservation, so long as they annihilate each other quickly enough to balance the cosmic ledger. These are virtual particles, and they are not merely theoretical abstractions, but genuine physical phenomena that produce measurable effects in the real world. From the Casimir effect, where two metal plates experience an actual attractive force due to the suppression of virtual particle activity between them, to the subtle decay of black holes through Hawking radiation, where one virtual particle pair forms just at the event horizon and one member falls inward while the other escapes, resulting in an actual loss of mass from the black hole itself. The mechanism underlying this strange permission from nature rests upon Heisenberg's uncertainty principle, which establishes that energy and time are fundamentally linked in such a way that the more precisely you measure one, the less you can know about the other, meaning that over sufficiently short time intervals, the universe becomes genuinely uncertain about how much energy exists. And this uncertainty naturally permits particles to spontaneously emerge from nothing provided they vanish again before the universe can detect them. What makes this reality particularly unsettling is not merely that these phantom particles exist in the quantum foam of empty space all around us at every moment, but that they represent a kind of fundamental instability built into the very substrate of existence itself, a perpetual seething activity beneath the surface of apparent calm, suggesting that what we perceive as empty vacuum is actually a churning sea of creation and destruction occurring at scales where our intuition. The vacuum of space, that seemingly infinite void stretching between stars and galaxies, is not actually empty at all, and this fundamental misconception persists in our collective understanding despite centuries of scientific advancement and evidence to the contrary. What we call a vacuum is instead filled with a seething sea of quantum fields and particles that constantly flicker in and out of existence, a phenomenon so strange and counterintuitive that even physicists struggle to fully articulate its implications to those unfamiliar with quantum mechanics. Virtual particles spontaneously appear and disappear in pairs throughout the supposedly empty void, borrowing energy from the universe itself for infinitesimally brief moments allowed by the uncertainty principle, and these ghostly interactions actually produce measurable effects that we can detect and measure in our laboratories. The vacuum also contains dark energy, an invisible force that makes up roughly 70% of all matter and energy in the universe, yet we cannot see it, touch it, or fully understand its nature, only observe its effects as galaxies accelerate away from one another in their expansion. Additionally, even the most perfect vacuum we can create in our most sophisticated equipment still contains particles and radiation, stray atoms and photons that persist despite our best efforts at elimination. The psychological mechanism that maintains this misconception lies in our everyday experience, where we have learned that empty spaces contain nothing of importance, that silence means absence, that darkness means nothing is there, and we project these intuitions onto the cosmos itself. We imagine space as somehow transparent nothingness, rather than as an active, dynamic medium teeming with energy and potential. Because our sensory apparatus evolved to navigate a world of larger scales where quantum effects remain invisible and imperceptible. Imagine standing in a vast, empty room where the walls themselves are slowly moving away from you in all directions simultaneously, and no matter how far you travel, the walls continue to recede at an ever-accelerating pace, growing more distant with each passing moment. And this is not a metaphor or a thought experiment, but rather the actual nature of the universe in which we exist. Space itself is expanding, not into anything, not through anything, but simply expanding as a fundamental property of reality, stretching the very fabric of existence outward in all directions at speeds that increase the farther away you look. And this expansion means that galaxies beyond a certain distance are moving away from us faster than light could ever travel, creating cosmic regions that we will never be able to reach or observe no matter how advanced our technology becomes. What makes this truly unsettling is that this expansion is not slowing down or maintaining a steady rate, but rather accelerating due to a mysterious force physicists call dark energy, a substance that comprises most of the energy density of the universe, yet remains fundamentally unknown and unobservable, driving space apart with increasing vigor. We have normalized this cosmic reality by incorporating it into our scientific models and discussing it in terms of redshift and Hubble constants, treating it as simply another phenomenon to measure and calculate, yet the deeper implication remains largely unexamined in everyday consciousness. That the universe is slowly becoming more isolated and disconnected, that distant stars and galaxies are being sealed off from us by the expansion of space itself, that eventually, in the incomprehensibly distant future, intelligent beings looking up at the night sky will see only darkness where galaxies once were, isolated in what will appear to be an empty cosmos, because the universe will have expanded to such a degree that all other galaxies have moved. Consider the observable universe as it exists at this moment, a vast and expanding cosmos stretching billions of light years in every conceivable direction, and understand that every single star, every galaxy, every cluster of matter and energy is inexorably moving away from us, pulled outward by the expansion of space itself. This phenomenon, detectable through the wavelengths of light that reach our telescopes, manifests as redshift, a stretching of electromagnetic radiation toward the longer, redder end of the spectrum as distance increases. What began as a theoretical prediction has become an observable certainty, confirmed through century after century of astronomical observation, revealing that the universe expands not into anything, but simply expands from within itself. The psychological weight of this reality emerges from recognizing that redshift is not merely a distant cosmic process, but an absolute law governing the fate of all structures, all civilizations, and all matter that will ever exist. Every photon we observe from distant galaxies carries this signature of recession. Every light we see from beyond our own stellar neighborhood is fundamentally displaced toward red wavelengths, telling us that separation is written into the very fabric of existence. We have normalized this truth so completely that it has become nearly invisible in our everyday consciousness, folded into the background assumptions of modern science, yet it represents perhaps the most profound loneliness the universe could impose. The mathematical certainty that everything we might ever observe beyond our immediate cosmic surroundings is pulling away from us has always been pulling away and will continue to do so for eternity. No force can reverse this expansion, no technology could ever bridge the growing distances fast enough, and the redshift observable today is merely the beginning of a process that will render the vast majority of the observable universe. Imagine standing in absolute darkness, completely still, believing yourself to be utterly alone in the void, and yet every single atom of your body is being bombarded by ancient light from all directions simultaneously, a relentless rain of photons that has been traveling through space for nearly 14 billion years, invisible to your eyes but absolutely real, permeating the universe in every conceivable direction without exception or mercy. This is the cosmic microwave background, the faint afterglow of the Big Bang itself, a remnant radiation field that fills all of space with a temperature of approximately 2.7 Kelvin, so cold it barely registers as anything, yet it is everywhere and nowhere, undetectable to human senses but measurable by instruments, a ghost made of light that refuses to dissipate. The mechanism that makes this phenomenon so profoundly unsettling operates on multiple levels of understanding. First, the realization that we are literally swimming in the oldest light that exists, that every moment of our lives is saturated with photons older than our sun, older than our galaxy, older than nearly all structure in the observable universe, which forces us to confront our temporal insignificance in ways that pure mathematics never quite captures. Second, there is the peculiar fact that this radiation field is so uniform, so perfectly distributed across the heavens, that it suggests everything we are and everything we see emerged from an incomprehensibly dense and hot point, which means the entire history of existence, all of our complexity, all of consciousness itself, originated from conditions so extreme that modern physics struggles to describe them. The most disquieting aspect is how we have normalized this reality, how it has become just another scientific fact in textbooks and documentaries, another entry in the catalog of cosmic phenomena that we acknowledge but do not truly feel, despite the fact. In the deepest reaches of space, our most powerful telescopes capture photons that have traveled for over 13 billion years, light that departed from distant galaxies when the universe itself was less than a billion years old. And in studying these ancient signals, astronomers have discovered something profoundly unsettling. We are constantly observing the universe as it was in its infancy, never as it truly exists now, perpetually gazing backward through an expanding void that grows wider with each passing moment, so that everything we see beyond our immediate cosmic neighborhood is already gone, already transformed, already dead in ways we cannot comprehend. The cosmic microwave background radiation that fills all of space represents the oldest light we can detect, the thermal echo of the Big Bang itself, a faint whisper of radiation released roughly 380,000 years after the universe began. And when we measure this radiation with extraordinary precision, we find evidence not of a perfectly uniform beginning, but of minuscule temperature fluctuations. Infinitesimal variations that should not exist if the Big Bang followed the laws of physics we understand, yet they do exist, suggesting either that our understanding is incomplete or that something happened before the Big Bang itself that we cannot explain. We have normalized this state of cosmic ignorance, this acceptance that we live within a universe whose origin remains fundamentally unknowable, whose beginning may itself have had a beginning, spiraling backward into infinite regress or circular logic that our minds cannot properly grasp. And yet we continue searching, continue analyzing, continue building larger instruments to detect quieter signals, as if we might eventually hear clearly the first words spoken by creation itself. Though every discovery only reveals how much deeper the darkness extends.